Good morning, everybody. I'm Corey O'Daniel, CEO and co-founder of Massdriver. Really excited to be doing our first Massdriver Day conference. Thanks everybody for attending. To kick off today, I wanted to introduce Kelsey Hightower to talk a bit about his career and what led him to platform engineering. So with that, I'll go ahead and turn it over to Kelsey.
Yo, happy to be here. And look, I had this pretty dope 5 minute slide deck all prepared, and I woke up this morning as one technologist does, and I'm scrolling through Twitter, and I'm looking at the comments to the tweet that I was going to be here today and hosting the Twitter space a little later on. And I came across this tweet. See if you can pull it up on the screen here. And the tweet said, look, platform engineering, that sounds great. I'm curious about how to do platform engineering, but maintain DevOps collaboration. I recently saw an org fail abysmally with platform engineering, having a huge chasm between dev and ops. And I thought about that for a moment. I said, look, I'm deleting my slides because at the end of the day, this is probably the number one situation that people doing the work are actually dealing with. If you work at a company and someone tells you that we're going to be moving towards platform engineering, if you're like me, what you hear is just another buzzword. And you end up in this situation where it's like, is someone trying to sell me some more tools? Are we really, really going to fix the culture this time? And so when I thought through my career, it's like, hey, what have we been trying to do? So look, I recently retired. I had a 25-year career. And when I started, it was this idea that you had a bunch of machines, you can log in via SSH, but you didn't become a system administrator until you made that machine do what you wanted it to do. And look, back then, early 2000, it was about shell scripts, run books, and just automating the machine to get our apps on there. And at the time, for a lot of people, that was state of the art, right? This is, for me, pre virtualization. And so during that time period, we had to evolve. And most of the times, we were just giving people access to run scripts, and we now call that kind of thing self service. Over time, though, I witnessed in my career people doing this concept of DevOps. When that term was introduced, it's like, what does it actually mean? I'm doing operations, they're writing software, and we're just trying our best to make sure that those two things happen on schedule and as predictable as possible. But eventually, people like me, the system administrators, we actually need to understand how the thing that we're managing works. But in order to do that, I actually had to learn Java or the runtime at least so I can actually tune it and meet expectations in terms of what we call observability now, but catching logs, getting metrics, and being a bit more proactive about dealing with failures instead of having the app crash, opening a Jira ticket, and say, hey, dev, your turn. And I think we also asked the vice versa. And I think this is probably where we went wrong. On the other side of that equation, we started asking developers to learn our tools too. And for a lot of people, we asked them to use lots of tools. We went to here's your laptop, to here's Vagrant. Now we're talking here's Docker. We were saying here's Puppet, Chef, Ansible. So many tools running on their desktops. Like, when do they have time to actually write code, right? The thing that they're specialized in. And I know that there's this concept that DevOps is supposed to be a shared responsibility, but if you've ever built anything at scale, if you've ever built anything over time, you know there's a lot of room for specialization. That could be at the database layer, the network layer, or the compute layer, or just writing software. And so how do we actually foster this? Now, I'll say one thing. Over time, it wasn't until I got to GCP, my last job, I was there for almost 8 years, that I really think it clicked for me what platform engineering was. In the cloud, you're servicing tens of thousands of customers you've never met. Maybe the support team will engage, but if everything goes right, you have hundreds of products and services backed by an API, a pricing model, an SLA, and the idea is that the user interfaces, whether it's a command line tool, a control plane with an API, or just a web UI where people can click around, that the whole thing would be self-service. And in many ways, I thought that that was the pinnacle of platform engineering, right? It's the platform engineering of all platform engineering. But it isn't the only thing that's required because those API services are large, those products are super complex. So, what is the job of a platform engineer that works at a normal company outside of the cloud or that has a different focus than selling infrastructure? I do not think the main goal of platform engineering is selling infrastructure to other people, whether it's an external team or an internal team. If I was a platform engineer right now working at an insurance company, for example, I think the goal of a platform engineer is to take existing platforms, whether that's a bare metal server or a cloud provider, and shrink that API down to a set of same defaults. If you were to do that, I think the workflow changes. Now, the whole day today is all about thinking about, is there a better way to approach platform engineering? And the main question around, how do we do it without creating silos again? I think we're going to have to collaborate in a way that takes everything and every decision that we make, we call them YAML files or configs. Can we serialize those decisions into the platform itself? Now, for the last 10 years, a lot of people thought that platform would be Kubernetes and Kubernetes alone. But the truth is, if you've been working in this space for a little while, take a look at your cluster. And my bet is you have a bunch of third-party stuff installed. You're probably trying something like GitOps, maybe even using Helm charts so you can get some templates in there. And so now you're left with a bunch of config, and now you think you have to start over. So hopefully the rest of the day, the team at Massdriver can actually talk about what does platform engineering look like when it evolves beyond a set of config files and GitOps, and maybe to that next generation where you actually get to build a platform where you shrink the API surface and you give people a tool optimized for your actual use case versus do anything you want self-service, causing more problems than you were trying to solve in the first place. With that, I'm going to bring Corey, CEO and co-founder of Massdriver, to the stage. He's going to talk about let's do the work. Welcome back, Corey.
Yeah, thanks so much. I really appreciate that, Kelsey. And again, thanks everybody for joining us today. We're really excited to be doing our very first conference. Let me go ahead and get my slides going. My name is Corey Daniel. I'm the CEO and co-founder of Massdriver. For those of you who are new to Massdriver, Massdriver helps DevOps and platform teams deliver self-service infrastructure and services with integrated cost, metrics, alerting, and troubleshooting tools. This day is a capstone on our very first launch week. We launched a ton of features this week, and one of the most requested things by teams that were checking out our platform was the ability to get all of the visibility that we offer without necessarily changing the way they manage infrastructure. So if you haven't adopted infrastructure as code yet, or you're using tools like Terraform Cloud, you can still get our visibility, cost controls, metrics, and troubleshooting tools. If you are watching anonymously, make sure that you register for the stream. We're going to be doing a raffle at the end of the day for a Steam Deck. So before I get into platform engineering, what I want to do is talk a little bit about my career and how I got here. I've been in the space for quite a while, but my original degree, I was focusing in physics and architecture. I had big dreams. I was going to build space habitats. This was early 2000s. This idea was not very likely. And my deans at the university had this very middle-class realism that you only get in Southwest Florida. The physics dean said I'd realistically be a teacher. And my architecture dean said that I would build strip malls, gas stations if I was lucky. This dose of candid realism made me think, how can I take all this math and science skills that I have and change majors and still graduate on time? Now, I happened to be working in healthcare IT to pay my way through college, and I was working for one of the largest medical providers in Florida. I went from dreaming of space habitats to working in a data center that looked a lot like this. And I was managing AS400s, Sun Solaris boxes, a host of AIX systems for this medical clinic. So I decided to focus my degree in computer science and healthcare information systems, and I would go on to be a HIPAA security and compliance officer. HIPAA was becoming really big at this point in time, very important piece of legislation and compliance. Now, my job was a lot of policy writing, a lot of policy enforcement, a lot of wrist slapping. But there was this one small part of my job that I really loved, and that was automating tasks with software. I would pull logs off of machines like this and aggregate them back into a PHP and MySQL-based dashboard that our team could look at to figure out what's going on across all of our different medical clinics. And so from there, I did what all software developers want to do. I moved to California to join a startup. I wanted to work on software full time. And in early 2006, 2007, I joined a digital signage company. And my boss walks by my cubicle one day, and he literally kind of popped his head over the side and he said, "You used to work in a data center, right?" And I said, "Yeah, I did. I mean, I've worked in this data center, but meanwhile, we're at this really cool co-location center. All the cables are nice, all the machines are beautiful, and we had 1,000 pops around the U.S. And about 2 hours later, an email comes in to myself and 4 of my colleagues, and it said that our lease on our co-location space was expiring, and Amazon, which is a bookstore, was selling these cloud computers. Is literally how it was phrased in the email. And the email said that I was going to be leading the migration to this new service called EC2. This was a big surprise to me. I was the only person on the team that had worked in a data center and was also a software developer. But this was also a big surprise because I had no idea what my boss was talking about. Like, the idea of a cloud computer being sold by a bookstore made zero sense to me. But fake it till you make it, right? And so we started working on this migration. And what we found was this co-location migration, going from this data center to going to VMs in the cloud, was actually very straightforward. We weren't migrating thousands of cloud services like you might migrate today if you're going from AWS to GCP. We were simply deploying our software to different computers. These servers have been set up in a data center by somebody, and now these VMs were built by our team, and we were pushing code to it. We were using SSH and rsync just to move files around, and we just pointed them at different servers. This is a very easy migration to the cloud, much easier than some migrations today. And we quickly followed this up with another migration. We started migrating our background workers to another service called SQS. This SQS migration felt very different. This isn't just using an API like some third-party service like credit card processing that wasn't in our company's wheelhouse. This was an API for how our software worked. A subset of our code, we were a Ruby shop, so thus the Ruby, a subset of our code just didn't exist anymore. We were replacing our cron jobs and our background workers with an event-driven architecture. And excuse the Ruby pun, but like a facet of our responsibility just kind of went away-ish. We weren't just writing code and using scripts to push to production. We had this new task that kind of sat on the side, this out-of-band configuration that we had to go do every once in a while. We needed a new queue, or we had a new environment. We'd have to go into AWS, click around to create a new queue, copy these configs from staging to prod. Again, this is early 2000s. Infrastructure as code is in its infancy. CF Engine exists. Puppet exists. But we never found these tools because GitHub didn't exist yet. We didn't know where to find open source tools. So we built our own, and we called it a dependency resolution framework that would build these servers and build these queues for us. Using a tool called Warning Shot, it still exists. I would not suggest wasting your time looking at it. But this moment was the moment that I realized something was changing about the way that we wrote software. More of our code would go away for consuming these different architecture patterns and cloud services. And this was also the day that I would start to become pigeonholed in this DevOps role, which wasn't turned and coined yet. And so when I think back on the last 15 years of DevOps and the last 17 or so years that I've been working in the cloud, not much has changed with regards to DevOps. We've gotten a lot of new tools, but we just keep saying it's this culture. Embrace it, do the work, and if it doesn't work, treat it like Apple treated AntennaGate and tell everybody they're holding DevOps wrong. What's interesting is there's more than just culture to DevOps. There's these principles that we had to embrace. There's experience, and this one's key. We're going to get into a lot more in this conversation. This isn't just educating your team, it's finding the skills, finding the people that have those skills to join your team, and then the tooling and the time necessary to actually facilitate making this culture possible. You had to be doing all these things for the culture to work. You can't just have DevOps culture and it magically come together. There's a lot of effort and things that have to be coordinated. And so when we think about the original DevOps loop, and this is actually a modified one that somebody jammed continuous testing into. It's in the wrong spot, by the way. You should test when you're writing your code. TDD guy, sorry. But what's funny with this loop is it never really accounted for managing cloud infrastructure. This is about getting our software on the servers, not also configuring these things on the side that we'd occasionally have to change. When do I need to make a change to my SQSQ? I don't know. Maybe we need to change the throughput, or maybe the billing model of a Dynamo table. And so we just kind of stapled infrastructure management to the side of this. So 15 years in, how well are we doing DevOps? We struggle to define it as an industry. So I'd say we're already kind of failing. And when you talk to teams, are you doing the freewheeling, the developer does everything themselves, or are you starting to do a centralized team operations rebranded? And when you look at the Stack Overflow survey, it's 50-50. And when you talk to people about this anti-pattern of a DevOps team, it turns out that more people are doing that than just developers doing this work themselves. And then there's this other group of about 12.5% people. I don't know what they're doing, but if this was a Netflix show, I would definitely binge watch it. So when we look at DevOps, and big note here, I am the DevOps is bullshit guy. You might think that gives me some bias. I've been in this space for a very long time. I don't think DevOps is dead, and I do think the work is very important. I think the way that teams have kind of haphazardly approached it, the inability to define it, and the cynicism and rebranding we've had around operations titles and our practices is what's setting us back. And I've seen people on Hacker News say, well, this guy must have worked at a shitty company. That's why DevOps didn't work for him. And I'll tell you what, I've worked at plenty of shitty companies. And guess what? Most of us do. Not everyone works at FANG. Not everyone has the luxury of 10,000 operations and platform professionals building tools so you as a developer can focus on business value. And the proof is in the industry reports that we hail. The DORA report, State of CD, the Stack Overflow survey, the numbers are concerning. This is from the most recent DORA report. 50% of companies are still only deploying 1 to 4 times a month. 50% of companies take more than a day to recover from a deployment failure, up to a week. That doesn't feel like we're doing DevOps very well. And I'll tell you what, it's not Google or Amazon taking a week to deploy some new software. It's not Facebook taking a week to resolve an outage. It's your insurance company. It's your doctor's medical record systems. It's the state and local governments. And it's your school systems. Every company is becoming a software company. And more companies are moving to the cloud. Brick and mortar commerce, insurance, healthcare, construction. With the advent of AI and the ability for non-technical folk to start building software, this revolution is going to move faster. But looking at the State of CD report, infrastructure as code, the lingua franca of cloud management. Only 27% of companies are doing IAC. That's 1 in 4. How do you manage resources in the cloud if you can't adequately reproduce your environments? And what about growth from 2022 to 2023 in the State of CD report? The way we enforce policy, security, compliance, and parity saw no growth. There was no growth from 2022 to 2023 in a year with massive layoffs. We got rid of people, but we made no effort to automate them. That's concerning. Working in ops, DevOps, or platform engineering, this can be hard to believe. But when you talk to teams that aren't doing DevOps, or they're struggling to move to the cloud and they can't find the talent to get them there, it becomes much easier to see. And so if you look at the Stack Overflow survey from 2022 until now, all administrative and operations roles are in decline. Engineers self-reporting their experience in DevOps, sysadmin, database administration, even SRE has shrank over the past 3 years. Meanwhile, the number of engineers on the planet has gone up by 13%. Isn't everybody moving to the cloud? Are people retiring en masse from operations? No, we're just making developers faster. And there's a market demand for developers. By 2032, 9 years from today, the US Bureau of Labor Statistics predicts 1 in 100 adults in the US will be a software developer. It's 5 times the rate of growth of any other career. We're going to have more developers, less teachers. More developers, less doctors. More developers, less lawyers. That might not be so bad. And that's just pure software development. That's not IT. It's not tech support. It's not tech managers. Can you imagine how big coffee shops are going to be? Jokes aside, 13 to 16 occupations larger than software development today are at risk of being replaced by the 3 A's of the middle class apocalypse: automation, AI, and Amazon.com. So where did all of this cloud and DevOps talent go? In 2022, only 46% of developers had a CS degree. It doesn't take 4 years to make one of us anymore. Many self-taught and bootcamp grads are showing up to work weeks from a career change. This is good. We need more engineers. But operations is on-the-job training. The only way you learn to operate and scale production is in production. We don't teach the cloud in universities. And if you did, your knowledge would probably be deprecated by the time you graduate. There isn't enough time in a 12-week boot camp to teach somebody how to add business value through code, whether it's React, Ruby on Rails, and also how to set up Terraform, build an API gateway, configure IAM and Lambda, and build a Kubernetes cluster. Many of these self-taught and bootcamp grads will go on to use something like a platform as a service, which is great for getting something up quick. But for the rest of us that are starting to massively scale systems or massively scale our engineering teams or have to start moving to more interesting architectures because of AI, fine-tuning, or the need to do things asynchronous, what do? We have a constrained resource as an industry, cloud and DevOps talent. How do we scale this skill set that's shrinking compared to the growth rate of developers? We need to scale this as an industry, and this is going to be key to a scalable, secure, and compliant future for all the services that we're starting to depend on. Let's say I need a Postgres database for production or for a new microservice. You build it, you run it, right? The mantra of DevOps. This is easy enough locally. I have Docker Compose. I throw my Postgres image in there and I'm writing software again, literally less than a minute. And I'm right back to working on code. But in production, it's a different story, right? I need IAM. I need secrets management. Is it compliant? I don't know. Will it scale? We're shifting a lot of accountability left in DevOps and DevSecOps, but we're not shifting the experience. Should a developer be spending all of their time doing this negative engineering, this engineering work that has to be done to create value? Because industry-wide, even organization-wide, this bespoke approach is just solving a solved problem. What if we had 5 or 10 services that are using Postgres? Are we just copying and pasting CI pipelines? Are we just copying and pasting Terraform configurations? Should a developer have to just copy and paste stuff to get a service that they need and then figure out what do we do with all those configs? What happens when we need to upgrade Terraform? Do we go through and find and replace the version number in 100 different CI files? Are they all in one repo? Are they organized per team, per project? There's a lot of overhead just to think about how to get Postgres so I can get back to writing software. And as a business, we should be able to say, we support Postgres, maybe some Redis, maybe SQS. It's always encrypted at rest. It's always encrypted in flight. Backups will always be on for 90 days and you'll get hourly snapshots. Authentication always uses IAM and TLS. We should be able to codify these rules and let engineers move swiftly. They should be able to grab something off the shelf just like they can from the store or order from a catalog, get it up and running with our practices, security, and compliance built in. And that's what platform engineering can deliver to companies. And that's what the cloud needs. And when I see DevOps teams, this idea that many consider to be an anti-pattern, I think they're actually doing it the right way. We should embrace their knowledge silos. Sometimes we even refer to that as expertise. We should spend more time and money investing in these DevOps teams so they can recruit developers and product people and start to build the products that scale their expertise, make it accessible to their engineering partners. But the rebranding that we did with ops to DevOps for a lot of people isn't a luxury that we can afford with platform engineering. We just saw the numbers. 2 weeks ago, Massdriver sponsored AWS, and the sheer cynicism from DevOps, operations, and even platform teams about the oncoming rebranding of DevOps was concerning. DevOps tools are currently left and right in the process of rebranding their homepages to have platform engineering on there without making any significant changes to what they're selling. The rebranding is happening right now, and we need to act before we're just stuck in cynicism forever. To truly deliver self-service, we can't settle for rebranded DevOps tools. And where DevOps goals were more of general guidance, Platform engineering goals are a bit more concrete. And the one that everybody talks about is developer self-service and treat it like a product. These are key. These are absolutely foundational to the work that you will do as a DevOps professional, as an operations person, or a software developer if you're trying to build an internal platform. But we also have to figure out how we can scale this constrained resource. This is absolutely going to be crucial as we see more companies moving to the cloud. We have to encode our organizational non-negotiables. Developers shouldn't have to think about compliance when they go to ship something, or security, or what the company's standards are, naming conventions, tagging conventions. They should be able to think about the code and getting it into prod. The rest of this stuff is done. We know what we need as an organization. Let's put them in place and let developers think about the code. We need to enable discoverability. As a software developer, how do you know in an organization of 5,000 developers what cloud services you support? Who is responsible for something being up? This is something that platform engineers in our platforms that we're building need to be able to enable for developers, to let them be able to quickly find what they need, who's responsible, and who they can talk to if there's a change that needs to happen that's outside of their control. And we need to eliminate all the toil created by DevOps, the copy pasting of CI pipelines, checklist after checklist and run books. But platform engineering can't stop at deployment and provisioning. Developers need to be able to own day two without getting bogged down in all the tooling of operations or passing that work off on somebody else. They need to understand their system's health. They need to understand the costs and be frugal and responsible for the cost of their architectures and software. And they need to be able to troubleshoot as simply as using the platform without having to page other people and bring them in. These platform teams need these cross-functional skills. Your most valuable product engineers are going to need to be involved. You're probably going to have to take some of your best engineers off of your customer-facing project and put them onto your internal product. It's going to take a builder mindset. You're going to have to build an MVP. You're going to have to get customer feedback, and the customer feedbacks are engineers. You're going to have to iterate fast. We do this in our products. We need to start treating operations like a product. And I'll share a couple secrets with you. You don't need to build a fancy UI like we did at Massdriver. And you don't need to get a PhD in managing Backstage. You can start very simple. The best way to get going is survey your team, find design partners in your developers, find the 3 lowest hanging pieces of fruit with the biggest impact on pain. That's your first MVP. Whether it's in React, whether it's in YAML, whether it's in some other configuration that we'll invent, that can be your first MVP. Let's not just rebrand DevOps as platform engineer. Let's actually do the work. This is the future that we're building at Massdriver. Thank you.
That was dope, Corey. It was nice to clear up the DevOps is BS thing. I think it's one of the sentiments that a lot of people feel when you put everything into this kind of cultural aspect of your job. At the end of the day, you just got to do the work. And look, honestly, it's probably getting better and easier to do the work given all the tools that are about. But now I guess people get to the part where show me how. They want to see the product in action. And so with that, I want to bring Dave to the stage. He's going to be talking about scaling ops, embracing platform engineering potential. So welcome to the stage, Dave.
Thanks, Kelsey. Really appreciate it. Hi, everybody. I'm Dave Williams. I am the CTO and co-founder of Massdriver, and I am a recovering DevOps practitioner. When I got into DevOps, the world was like kind of simple. As the cloud proliferated and we got more services and we were able to outsource more of our code to the cloud, the tools started to feel narrow and the problem space felt a lot more complex. The number of engineers that I ran into that had kind of the same shared experience that I had was pretty limited. I haven't seen a ton of them. And this led me to a foundational moment in my career that I want to share with you today. We've had the kind of the history of careers and the history of DevOps kind of as an industry, but I want to share the origin story of Massdriver today. I want to talk about some of the problems that we saw, and I want to talk about how we went about solving them in our platform. So to go back 3 years now, I think, Corey and I were working on a side project. We wanted to do a simple photo sharing app. And we thought we had a good idea. We were going to write some code together. It was going to be a lot of fun. And we realized we were going to need event-driven systems. We might need some serverless stuff for image optimization. And that was going to require DevOps work. Now, keep in mind, Corey and I have multiple decades of experience deploying cloud infrastructure and software. And we both looked at each other, touched our nose and said, not it. And it was a tie, unfortunately. And we were at an impasse. And the more that we talked about this problem, the more we realized that there was a problem with the way that we did operations. It didn't make us feel good. It didn't make us feel like we could be productive. And it became incredibly obvious that we now had to figure out how to scale our operational expertise so that we could just go write the software we wanted to write in the first place. We didn't set out to build SQS queues. We didn't set out to write IAM policies. We set out to make a way for people to share photos with each other. That led us to Massdriver. So I want to talk today about what we've built, and I want to use a practical example of a native service built in the world where Massdriver exists. In front of you, you can see our cloud cost service. This service is unique to Massdriver in that it doesn't look like the core platform. It's asynchronous and event-driven. It only runs sometimes, right? This made it really fit kind of the serverless model, right? Why pay for compute all the time when we can just run it when we need it? Massdriver allowed us to kind of deliver this complex architecture seamlessly and quickly with an engineering team that had limited exposure to serverless infrastructure. I've had a ton of experience with it. And so this allowed me to quickly make blocks that were self-explainable, that were really easy for an engineer to grab and put together. This service, the infrastructure was spun up in minutes. That allowed our engineer to get immediately to the business logic of calculating cloud costs and attributing that to your different blocks in the system. So let's step through all kind of the pieces that even enable something like that. So the first thing we had to come up with was this concept of blocks, right? We wanted to be able to encode our expertise once in our services and then grab them many times so that we can just quickly build novel architectures. This was a serious deviation from the golden paths that people were talking about at the time, right? Golden paths, you make a giant thing, you deploy it over and over. The second you need to change, you get some operations professionals in, and they make you a new golden path. We wanted a system that allowed us to build the stuff we need with pieces and parts, with all of the security and compliance built in. So let's look at the anatomy, or let's talk about the anatomy of something like an SQS queue here at Massdriver. When an engineer pulls an SQS queue and puts it on their canvas, they're not just getting an SQS queue. They're getting a dead letter queue, and it's not an option. Redundancy is an important part of good event-driven systems. They get alarms immediately. When a message hits their dead letter queue, they don't have an option of whether or not they want to hear about it. They have to. There's a problem in their system. And finally, they're getting their IAM policies. No more star policies. We define read-write policies, and the downstream service can come in and select the one they need, moving towards policy of least privilege. Our type system allows us to define things that the SQS queue needs to run. So at Massdriver, we always use an SNS topic in front of our SQS queue. It's not an option for the developer. The reason we do this is because if another consumer of the information comes into being, we don't want to have to migrate to a multi-consumer queue like Kinesis. We can just add another SQS queue and the topic will deliver to both. This prevents our engineers from shooting themselves in the foot early in the design process. And finally, the last big piece of blocks is some kind of output to tell a downstream block, how do you connect to me? What's my resource ID? What available security is there? Security groups, IAM policies, right? Some useful metadata. What region is this deployed into, right? All of that should happen seamlessly by just dragging from one connection to another. The thing that this opens up that is truly revolutionary in my mind is interoperability now between my various DevOps tool chains. I can write Terraform for RDS, I can write CloudFormation for Lambda, and I can use Helm for Kubernetes. And through these lines, all of these blocks can speak to each other. Our engineers get a similar interface regardless of the tooling. No more learning 100 command line tools. It's just one platform. Now, we've built a bunch of blocks, and I think building blocks is important. But like, how do you find blocks, right? What do you have to do in your organization today to figure out what NoSQL databases your company supports? I imagine it looks a lot like going to Git, typing in Mongo, hoping that there's a hit somewhere in one of the repositories, but I doubt it's going to work, right? Go to DynamoDB, no hits, right? Just continue that cycle. One of the important things for Massdriver was to figure out how to create a catalog system for all of our blocks. We've written these small pieces, and we need to be able to find them. Finding what queues are supported should just be as easy as typing stuff in. At design time, it's important to understand whether or not the blocks you're pulling are meeting compliance requirements for your service. Like a good catalog in an e-commerce SaaS, right? You got to be able to see this stuff, grab it quickly, and go to checkout. That was our goal for discoverability of our modules in Massdriver. When it comes to design time, being able to start with documentation. These boxes are exactly what it looks like when we go to the whiteboard. We don't go to Lucidchart first and design our subnets and our IP tables. We have a bunch of boxes with arrows pointing to them. We want to make sure that our living documentation is simple to consume. We abstract away the parts that are superfluous, and we make sure you can see the relationship from your software to your infrastructure. Let's talk about the management of things in Massdriver. As I said before, Massdriver provides a nice, consistent interface, regardless of your tooling. The thing that this allows when I'm in operations mode is I can be very intentional about the fields that I choose to expose to my engineers and the fields that I don't. So you'll see here, you don't get to change security settings on our SQSQ. What you're going to focus on is your visibility timeouts, your message retention time. You're going to think about message sizes, right? These are things you need to run your app. You shouldn't be bogged down with a module full of flags and things you don't understand that require you to read a white paper. The nice thing about this interface is we can do useful things for our engineering team. We can do things like data conversion really easily. You might not want to think in seconds. You might want to think in hours. You might want to think in minutes. The cloud APIs have a standardized time format. Why should my engineers have to do math? We can keep our engineers safe by doing rich validation. You'll see here, I tried to do a 30-day visibility timeout. The cloud does not support that. I shouldn't have to wait for Jenkins to run Terraform for the cloud API to tell me something that we know as operations professionals. Managing any infrastructure is challenging. It's especially challenging with tooling sprawl. Imagine having an outage at 1 in the morning and having to figure out what happened. How many tools do you have to pick up today in order to figure that out? It's the worst place to have to do that. At Massdriver, we want your history to be right there for you. We want you to be able to compare points in time. And we want you to be able to spot an issue and fix it in the same tool. Right now, that probably requires Datadog, probably requires putting up pull requests, going back to Datadog to see if your pull request actually did what you thought it was going to do. This is cumbersome, and these platforms make engineers more effective by combining all of those tools into one place. It provides consistency, right? We don't want our engineers to have to learn 10 tools. We want them to be able to use one tool and have shared experience with that one tool. Let's talk about day 2. You've designed, you've deployed, you have this thing running. What can a platform provide, and Massdriver specifically, to your engineers in day 2? So one of our core features is we record everything that was deployed every time you deploy one of these blocks, giving you an infrastructure bill of materials. Immediately, I know everything that I had to build in order to create this SQSQ in a secure and compliant manner. This is the superpower of Massdriver. It allows us to do really interesting things. So as I'm sure you've seen on the screen, we have costs baked into our platform. We use the infrastructure bill of materials, we figure out what each piece costs, and we bubble it up. So now you can see, I'm spending more money this month on my SQSQ than I did last month. That might be an issue, right? That might be a place we can save a little bit of money. We have the ability to do things like create catalogs of all of the relevant metrics for a block. No thinking about what's in it, right? I have an SQSQ, there's stuff in it, and these are all of the metrics that I have available to me. Imagine you doing this using Datadog, right? The problem with a tool like that is it requires fundamentally an understanding of the underlying architecture in order to make sense of those numbers. We believe that for engineers to be effective, they should see the context and the relationships between infrastructure alongside those numbers in order to understand the impact downstream to any failing service. This makes it really easy for Massdriver to help people mitigate issues faster. And with just like a little bit extra effort, we can go back into this monitoring panel and we can create an alarm. We can say, this is greater than that for 5 minutes. Let's create an alarm. Now behind the scenes, CloudWatch has created an alarm, and I can be alerted in the same platform that I manage my infrastructure to any issues happening. This is incredibly powerful from the perspective of a product engineer. And the key to making this all happen is committing to our silos, but creating an interface in between them, right? This is the problem we had with silos in the first place. Throwing things over the wall doesn't work, but defining clearly an interface between two sets of expertise enables people to go faster. In the same way we decouple our software, we can actually decouple our teams. I think that approaching things this way will revolutionize our industry and scale our operations potential. As Corey said before, it's a limited skill set that is only getting smaller. We need to scale this stuff the same way that we scale all of our software. What e-commerce did for brick and mortar, we can actually do for operations. That's it for me. Join our Twitter space, and we're going to continue the conversation with a fireside chat with Kelsey Hightower.
Awesome, Dave. Thank you. And again, for anybody who is watching anonymously, make sure that you register for the stream. We are going to be doing a raffle at the end of the day, and we'll be sharing the Twitter space here in just a few minutes. It's kicking off at 10 a.m. So stay tuned.
Hey everybody, we're going to get started here in just a second. We're going to get started here in just a second. Adding everybody to the call now. Hey everybody, we're going to be getting started right at 10 o'clock. Thanks for joining.
Hey everyone, welcome. We'll be getting started in a couple of minutes here, so hang out for a second. Welcome, Massdriver team. We'll be joining we'll kick things off in about another minute at the top of the hour. All right, looks like we are at the top of the hour, and I see many members of the Massdriver team. I see Chris, I see Dave. Hopefully, they're on mobile devices and they all get set up. I see Corey's here. Welcome to the fireside chat today. I'll be hosting. I think someone on the Massdriver side was trying to speak. Go ahead.
Oh, sorry, I was just joining in.
Awesome, Corey. So, will you be on this Massdriver, the hosted account?
Yep, I'll be on this one today. I'll be the Jimmy bot.
Awesome. All right. So look, we're going to be covering a couple of things today, a couple of topics that I'm super interested in. Number one, what's going on with Open Tofu, platform engineering as a whole. Before we do that, though, I do want to congratulate the Massdriver team for having their Massdriver Day after a very successful reInvent. Corey, if you don't mind, tell people a little bit about maybe Massdriver, reInvent, and the Massdriver Day today.
Yeah, so Massdriver Day was the capstone on our first launch week. For people that aren't familiar with Massdriver, we're a tool that helps DevOps and platform teams enable developer self-service with automated cost management, health, and troubleshooting tools. So yeah, we sponsored AWS reInvent this year. It was a very successful event for us, and we were excited to see how many people were passionate and ready for the move to platform engineering. And that was a lot of people that were still trying to figure out, like, how do they go there? How do they move past DevOps or the operational teams they have today to embrace it?
All right, just so for the audience knows, I'm Kelsey Hightower. I'm going to be hosting and moderating today. I'm also an advisor to Massdriver, and people often ask me, like, Kelsey, how do you and why do you advise startups? And I said, well, I spent a lot of times at places like CoreOS, at Puppet Labs, and anytime there's a big industry trend, you tend to see a new spurge of tools that just come on the market. During the DevOps time, we got Puppet, Chef, CF Engine, Ansible. All of these tools came trying to maybe solve the problem, but also sometimes we get in trouble or we get caught up in the hype wave. CoreOS came out during containerization. You all know Docker well. But I noticed that startups are usually at the forefront of experimenting, trying new things, and pushing boundaries. Like, that's the whole point of having a startup. And they're typically a lot faster at trying to grab these market opportunities than the incumbents, right? The companies that we're used to. And so when I met the team, I said, why another platform? And I'll be honest with you, when I saw Massdriver for the first time, I was like, look, this looks like a PaaS, and most people aren't interested in the PaaS, with one caveat, unless they build a PaaS themselves. And this is why, even though people love to hate it, platforms like Kubernetes, you can consider Nomad, and before that, we had things like Mesos, where I think people love the fact that there was an infrastructure SDK. They can assemble their own platform, make it look like or feel like however they want it. But we zoom out, and I've been doing that for what, 7, 8 years. This whole Kubernetes space, I think we're about to hit the 10-year anniversary. And when I used to visit lots of people on site all over the world, and I looked at their setup, their platform engineers would say, hey, let me show you our setup. Worst case, it's a Rube Goldberg machine. Helm charts, YAML files, GitOps, plus Jenkins, plus GitHub Actions, you name it. Everything end to end just to get a deployment out the door. And a lot of times, most of it was straight up overkill. But what they're really trying to build was something that had a new API, one that developers could actually understand, one that was a bit more flexible than something like Cloud Foundry. And so they were all building at something. And so when the Massdriver team really started, it took like 2 or 3 meetings. But once we got to the details of it, I was like, oh, this is what people are trying to build. This idea that we can encapsulate the different configuration languages, whether it's Terraform, Helm charts, or Kubernetes, zoom out a little bit and turn all of those configs into catalog components that you can actually stitch together. And that's when I had my kind of aha moment. And I was like, you know what? Platform engineering is probably going to require tools that allow people to actually build platforms. And I think that's where we are. So I want to introduce Chris to the stage. I know Dave is probably still plugging in. Chris, welcome to the stage. Introduce yourself. Tell people a little bit about who you are and what you're working on.
Absolutely. Hopefully, everybody can hear me.
We can.
My name's Chris. I'm one of the 3 co-founders here at Massdriver. My background is in operations. So similar to the other guys here, I actually started as a developer, and I was pushed more into the world of operations as need demanded at the companies that I was at. And it's interesting, the first role I was at doing operations, they actually branded our team as a platform team. And I didn't really understand it at the time, but what's interesting is we actually kind of started moving in the direction of platform engineering even back then, of building some tools to allow developers to be able to start taking some amount of, I would say, perhaps co-ownership in making sure that they were getting their code out and deliver. It was kind of bringing a platform to the developers. And so ever since then, I've been passionate about trying to kind of bring these two worlds together, development and ops, because I've lived in both and I've seen the pains of both. And I've wanted to be able to help unify that experience and really help kind of push the industry forward.
Chris, it's a very common story throughout my career. I remember working at a company called T-Sys out in Atlanta, financial services, prepaid cards, settling reward points for big banks and big merchants. And I remember when I joined there, I had been a system administrator. I racked and stacked stuff in server rooms, like large ones, including places Google, did a bit of web hosting. And then when I get to this financial services company, everything's super strict, right? We have all their laws and regulations. People are still using runbooks out of SharePoint. Everything was kind of divided. Developers sat on one floor, ops sat on a different floor. And I remember there was a guy named Dan Marchant. This is like the purest form of software developer, kind of like yourself. And I remember Dan was like the first person that I could actually collaborate from the ops side and say, listen, Dan, we got to teach these apps how to actually understand the infrastructure. And that means we're going to have to change the way these apps work a little bit. They're going to have to present metrics to us. We need to start structuring logs in a certain way. I need to be able to restart them. So we're going to need health checks. There's so many things that I needed to happen. And honestly, there's only so much you can do underneath an app using Linux, management tools, various things like that. And I really needed to actually have a developer, actually, in that case, also teach me how to actually write code so that I can actually optimize these systems. What's the thing that made you say, you know what? I'm not going to say this is not my job and just close off. What gives you the ability to say, look, this is important, and I'm going to try to find my dev cycles and contribute them to the upside of the equation?
Well, I think one of the things was, at least going back originally to where I was at within that role, was it was it was complex, it was tedious, and it was time consuming to try to get our software out and running. You know, it would take a long time to deploy, it would take a long time to bring up. We didn't have great visibility into the health of our systems as they were running. And when we were deploying code, we would oftentimes drop connections as new versions of the software were rolling out. And particularly as you start reaching scale, like these sorts of issues really start building up and really slowing down the team. And so I guess I found a lot of value in trying to contribute back to the organization, not even so much directly from contributing to the product, but from enabling the developers to be able to operate faster, get what they need and get back to work, have trust that when they deploy software, they're not going to be causing issues. And if issues do arise, the ability to detect and triage it as quickly as possible and understand the health of systems. And honestly, a huge part for me of what got me passionate about the space was this was about the time Kubernetes was coming out and the movement to containers. And I think Kubernetes kind of brought to the forefront a lot of the things that you should be considering when running applications that companies probably weren't really doing much before, besides just shipping code, you know, running some scripts on a VM and hoping for the best. And Kubernetes kind of brought to light, hey, there's other things you can be doing to automate even understanding the health of your systems. And I don't know, I found a lot of fulfillment in helping that piece of the company and the technology.
So, Chris, look, I got this. Is the number one question. When anytime I join a company throughout my career, or I meet other people that are trying to do this kind of work, how the hell did this happen? How do we even get in this spot? Think about it. Let's say you're the first dev at a company, right? You got 15 years of experience. They want to build another CRUD app. You need the money. You agree. Node.js, Java, doesn't matter. You're in. And before you know it, you got this problem. Rinse and repeat, thousands of companies around the world, same thing. Got an app, you've done this before, you sometimes are working by yourself, maybe you add people to the team, and before you know it, you literally got a mess in your hands. You literally have people doing ad hoc deployment processes. It's just good enough. And it just feels like chaos. So when the first system administrator joins and they open up that GitHub repo, they're like, what the hell is this? Have
Yeah.
you all been using Makefiles this whole time? Like, how did we get to this point, Chris?
Hey, I still use Makefile sometimes, but and I think that's partly it. Is that the the skill set? I think coming into the DevOps space or the platform engineering space now, you have two groups of people. You have developers and you have, I would say, people that kind of came from a sysadmin background and just had these new responsibilities thrust upon them. And particularly from perhaps a sysadmin background, a lot of the work that you're doing is just putting together Bash scripts or Python scripts to glue pieces together and make your job easier. And I think some of that mentality and culture kind of moved into this whole space of DevOps. I think we also have a space where a lot of the DevOps tools are focused on solving like one small, difficult piece of a much, much bigger problem. And so you end up getting a very fragmented tool set. You're going to have, 12, 10 or 20, 30, 40 different tools all to solve one small pain point, and then a bunch of scripts to glue it all together. And I think it's taken us time as an industry to identify, hey, we're all experiencing these same problems. We're all like writing our own little bespoke scripts to solve these problems. And I think the whole industry now is recognizing, hey, maybe we should actually collaborate on building solutions beyond these problems. And so I think that's where we're at with platform engineering.
I'm going to bring Dave in here because I think Dave was probably the first person that gave me kind of a hands-on demo of the platform. And when I think about this space for a moment, and you talk about all those moving pieces, if you ever go to the cloud native computing landscape, you got to prepare yourself, close all your other tabs, shut down any apps, any games in the background. You got to shut it all down. This is going to require all your memory to load up the CNCF landscape for real. There's like, I don't know, hundreds, maybe 1,000 projects at this point. All of them are like these little pieces. I know people like to claim the Unix philosophy, but at this point, there's just a lot of overlap. It's not really interchangeable. There's no concept of the Unix pipe outside of YAML and JSON in between these things. But one thing that I've noticed is that when you're writing software for the first time and you're a purist, you just want to do everything sometimes from scratch. I've met a lot of C developers. They don't believe, some of them, not all of them, don't believe in like standard libraries or third-party packages. Some of them are just like, yo, we're going to roll our own crypto stack. We're going to roll our own TCP stack. We don't trust anything that we did right. And sometimes there's a time and place for that. Then you have some people that are like, look, we've been writing web apps for so long. There's only so many HTTP routers that you need. There's only so many TLS mutual auth libraries that you need. And I can go on. And eventually you land in this world where you end up with frameworks. That can end up in another problem. If you look in the JavaScript community, there are like 1,000 JavaScript frameworks. But in the infrastructure space, I don't think we have a lot of frameworks. And if we were to think about Kubernetes as a framework or SDK, Nomad from HashiCorp as a framework SDK, what do you end up with? And I think, Dave, when you showed me off Massdriver, like, look, Kelsey, people are going to be using a bit of Terraform. People are going to use a little bit of Kubernetes and Helm charts and all of these things. Better than Dave, they're still going to have to abstract it all away to give people a tool that they can use. Maybe Dave, join the stage, introduce yourself, and talk a little bit about the engineering approach to this platform engineering problem.
Hey, thanks, Kelsey. Yeah, so I'm Dave. I'm the CTO of Massdriver. Let's talk about that a little bit. So I came from the Ruby on Rails world. And one of the big things about kind of watching Ruby grow was like, I stopped having conversations that didn't matter in my day-to-day experience as an engineer. We stopped talking about, prefixing table names and things like that. And I think like that convention over configuration mindset was huge. It enabled a lot of companies to grow really, really fast and deliver software really, really fast. And so in operations, like you have a similar problem, right? You have tooling sprawl, right? So it's like we use Helm for some stuff, we use Terraform for some stuff, we might use CloudFormation for something, right? We might use a CLI for something. Thinking about how to structure projects in Terraform, right? I've had way too many fights about this. I've implemented Terraform in many, many businesses, and like every time it's like, is it an environment? Is it a project? Is it in the entire org? How big is a module? And I feel like the missing piece was like some standardized framework for saying, this is the size of a module that I want an engineer to use. This is the communication mechanism between modules, right? And that allows us to enable a product engineer's creativity, right? I think like golden paths are an extension of that kind of really rigid philosophy that comes around when you have trouble managing environments with infrastructure as code. And so we really wanted to enable that block mindset, let's get all of the cool individual pieces that we use, let's tie them up together, and let's be able to make product engineers move fast.
I think this part where, and hopefully people understand this nuance here. I think people were really happy with the new tools we got. I spent a lot of time in that space. But when you pull these tools down, like when we start to say developer, let's get really honest what we're talking about here. You take these tools and you got to make decisions. So this whole DevOps movement, I think the reason why people over-index on the culture, most people don't have a framework for making decisions, let alone the tools in which to express them. So if you go around and say, hey, we're going to use this SQL database, the decision on what database you use, that could be a debate. It could just be the one you already have, the one that is free, the one that your language of choice has the best drivers in. You pick your database, and then you have to make another set of decisions. What should the schema be, right? Is it laid out for performance? Is it laid out for security, permissions, controls, the whole nine? And then the tools that you manage it, you're still making the same decisions. And I think in the past, those decisions ended up in scripts. That's where I put them. You got a bunch of scripts. If you run the script, these are the decisions I've made. And I'll allow you to make a few decisions too. And we call those command line flags or environment variables. But I think what's happening now, these platforms we're being asked to build, these are the decisions of the whole company now. The whole company has decided that we want to do AI, ML. We want to train our own model. Okay, that's a bunch of decisions. So we're going to use NVIDIA. We're going to use this kind of storage. The model is going to go here. The data is going to come from here. These are bigger decisions than we were making before. And when people talk about the complexity of platform engineering, this is what it is. Everyone's making decisions now. And now you have to serialize those decisions into the platform itself. And this is where I think we end up in this spot. And Dave, I remember the first thing that made me go, aha. I'm like, look, I'm not switching from Massdriver to Massdriver away from Terraform. If that's what I know, it's going to be hard to delete all that code and start over, because then more than likely, I'm just going to make another mess in a different tool. I'm not going to switch from Kubernetes to a PaaS that I don't know how it works underneath the hood, because the moment I need to extend it, then I'm going to have another problem. We saw this with Cloud Foundry. Cloud Foundry was amazing when it came out. But the moment you try to do something that Cloud Foundry wasn't good at, you found yourself with another system, either Lambda for functions, Kubernetes for pods and containers, or something else. And it becomes a situation where the platform is inextendable, then a lot of times people don't want to touch it. But the thing you showed me is like, yo, our model, this thing where we take and turn these things into catalog building blocks. Yeah, this box over here is a Helm chart, but you don't have to know that. This box over here is a Terraform thing, but you don't have to know that. This could be a secret. This could be a Kubernetes manifest. At the end of the day, I think you all treat each of these tools like little mini functions that you would find in like a programming library or a standard library, and you ask people to create an interface to them. And if they do the interface right, then people using those blocks can then treat them like little functions, right? Here are the variables that they take. This one can call this one. This one can connect from this one. And you don't have to think about exactly what tools at every layer, but you do have that flexibility and end up with a unified platform. How do you end up in that spot versus just creating a brand new tool to compete with all the others?
Yeah, so that's an interesting question. So like one of the things that we talked about early on at Massdriver was like this idea of like infrastructure as code being kind of dated and really difficult to kind of like disseminate across a tech org, right? Like when I give my engineers Terraform, I'm giving them a chore and not a thing that makes their life as a product engineer any easier. And so like we really centered around like this idea of like infrastructure as software. Like is there a layer we can put around the tools that we know and allow us as operations professionals to go fast that will provide the same experience for our product engineers, right? And like that's the premise of Massdriver in a nutshell, is like, can I provide people who are not operations professionals a consistent experience while I get to use the tools that I move fast in, right? I think like the idea of learning a new tool is unattractive when like you have to meet product timelines and you have to like meet your customers. Like we all need to move fast, and that means like meeting everyone where they're at and allowing them to collaborate easily.
The thing I want to make sure people take away from a statement like that, it's not that we think people are incompetent, people don't have the skill set. It's literally a waste of time. When you program, like I like to program in Go, when I go to the standard library and I need to start dealing with TLS certificates, I literally import the TLS library, read the certificate, it gets loaded into all the right objects. I assign it to an HTTP server, and I literally move on. I think what we've been doing is literally saying, hey, folks, here's the RFC for X509 certificates. And they're like, dude, what's X509? I thought you said TLS. I was like, yeah, there's a spec underneath that. And here's how the certificates are laid out. And you need to go build a parser on your own. We'll tweak and customize it. This is what we've been doing. And again, it's not a skill, like you don't have the skills, you're not competent. It's literally wasting time. There is no reason why we have to recreate the infrastructure world every company or every time a new product comes out. And I think that's kind of the big takeaway here. And honestly, if we're thinking about our roles, if you're a platform engineer, that should be the best thing you can ever do, which is make it so that people do not have to reinvent the wheel to deploy software for the 30th year in a row. I want to pivot over to something really quickly because I know Terraform is an integral part of the Massdriver platform. Actually, that's the first time I heard about Massdriver is around the time of the Terraform fork, maybe a little bit earlier than that, because I knew you all had it kind of baked in as this kind of control loop so that people didn't run Terraform from laptops. You wanted people to move that into more of a platform approach to make this whole model work. And I know that when HashiCorp changed their license from, I think it was the MIT license to the business source license, which was if you're a vendor, we don't really want you shipping Terraform using the branding, using the code straight up as it is to power your commercial business. If you're a user, to be fair, you can continue using Terraform under the original terms. Even those not impacted somewhat directly monetarily, I think a lot of us felt like, oh, I thought Terraform was our project. And it turns out it's not yours, even if you've made contributions. It is still owned by the particular set of maintainers. And I'm going to give them a lot of credit for like 10 years plus. They've been giving us Terraform for free. So shout out to anyone that works at HashiCorp. You enabled a lot of people to actually have jobs in this space. So hats off there. But you all felt the need to fork it. And it's called Open Tofu. And I noted now that it's a Linux Foundation project. I know it has a new name. I know it has a roadmap. Maybe if anyone wants to jump in here, maybe Corey, where are we at? Is Open Tofu still a thing? Did you do it out of revenge? Or is it a real thing that the community can count on?
Yeah, so I mean, I think it's really funny because we saw the news hit, and we didn't know where we sat, and over about a week, the team that was managing the license for Terraform was continually updating this FAQ on who and who wasn't impacted. Right, like there's not really a license per se. There's a license, but then there's also a blog you have to go read to figure out the license. And so we were kind of, I remember sitting things Friday night or Saturday morning trying to figure out like what this meant. And so I had reached out to a friend of mine that works for Spacelift, who is a tangential competitor. And I was like, what do you guys think about this? And I was like, we're definitely talking about it. And so we got a group of about 5 or 6 orgs together. originally to figure out how we would take a fork. Now, the really interesting thing was, as these FAQs were getting updated, one got updated that applied to us. We're not a competitor with Terraform Cloud. We compete more with Waypoint, right? We're a tool for platform engineering. But we still wanted to be a part of this. Like, Terraform is an important part of the cloud. I know that there's plenty of IAC tools out there, but it's the established like lingua franca of how we manage cloud infrastructure. And I think it's important to be open and make sure that we can have competition. So Massdriver wanted to stay involved in the process, even though we weren't necessarily impacted by the license change. That's kind of how we got into it. It's been a lot of work, and we've seen a lot of progress. So if you look at the repo, it might not feel that way. We don't have a stable release yet, but we have a lot of we're swimming upstream right now, right? We had to get a registry. So one of the kind of landmines that we found was the HashiCorp registry or Terraform registry was updated so that non-Terraform tools can't use it. So we had to stop. We had to build our own registry. That's going to be open source as well, which is great. So now you'll be able to run your own registry internal to host your Terraform and OpenTofu modules. We did get into the Linux Foundation. We have our application into CNCF and hope to be announcing that soon. And we do have a date for our first stable release. So we have a 1.6 beta out, and we are targeting January 10th for the first official stable release. There are 6 full-time engineers now working on OpenTofu. There's a number of job openings. So if anybody's listening and you want to work on OpenTofu full-time, there are multiple companies that are hiring for this role. And it's just been really great. I mean, there was I feel like a lot of drama and a lot of slander around the time this happened, but we're working with people that we don't necessarily see as direct competitors, but you might choose their tool over ours, depending on the makeup of your team. But what we found is it's a warm community. I love these guys. Like I ran into Space Lift at reInvent, and like hugs all around. Like it's like we are embracing this culture of open source community. It's there. And I think that one of the big things that was disappointing to me in this whole transition was the Terraform repo hasn't really been open to community for 2 years. There's so many PRs and issues that sat there stagnant, and HashiCorp even resisted taking PRs from the community for a while. And so it's really nice to be able to see a group of companies putting money into making this tool that we've all built software on and depend on better, more open, and have the functionality that we've been waiting years for it to have. So we're about to start working on the 1.7, and yeah, definitely look forward to the future of OpenTofu.
I think you described a little bit of a fear a lot of people especially the infrastructure space. When I think about infrastructure, typically tools in that space offer a different promise than things higher up the stack. We expect freeways, roads, and bridges to be fairly open. We may have proprietary automakers, so you pick and choose what brand of car you want. You got to pay a little extra for that. Even though there's a hidden tax that pays for the roads and things, we expect that infrastructure to be open, flexible. So if I buy a different brand of car, I think the road should still be available. And I think when it comes to infrastructure, things at the bottom of the stack, Linux, Terraform, Git, we want all of those things to be interoperable between players. So if I do Git push to GitHub, I also want that to work for GitLab. When that stops, I think that's the problem. And a lot of people, I think, get wound up in the I'm worried about lock in, but I think the bigger problem is lock out. If you've invested 5 years into making Terraform your kind of go-to tool for managing APIs for pretty much everything you do, you're using a Terraform registry. As far as you've known until this point, you could just use any other tool that supports Terraform and everything just works. And in that world, you feel like you bet on the right horse. The moment you see a competitor show up and say, hey, we're compatible with Terraform, but guess what? We can't pull modules from their upstream registry. And at that moment, that's when I think an average person who just wants to do their job feels like they've been wronged in some way because they didn't pick Terraform because they plan to use only one vendor's tools for the rest of their lives. They picked Terraform probably because one of their peers gave them advice that it was a tool to solve their job. And when it comes to platform engineering, I think this same problem exists inside of teams. And you spoke about this. We wanted to contribute, or other vendors wanted to contribute upstream, and they couldn't. And this is the problem that I kind of see with DevOps in some ways. Platform engineers will show up and say, hey, we're adopting Kubernetes, for example, but you really can't contribute to the setup. However we set it up, if we choose GCP or GKE, that's what you're going to be stuck with. We'll give you some templates, but that's all you get. And a lot of times I've noticed that people that are forced to use platforms like that, that's when we start doing shadow IT. That's when people break off to start using other platforms that they feel they get more control. How do you avoid this problem in the world of Massdriver, right? Like, how do you make sure that you're not building black boxes that no one else in the team can contribute to?
Yeah, that's a really good question. So we have kind of two interfaces to the product. There is the operational tooling side, right? So we want to support all the ISC tools out there, like you and Dave were talking about earlier, Terraform and Helm, Plumi CDK. And we think this is important because sometimes there'll be a great CDK module that you just want to grab out of a repo and you don't want to rewrite it, right? And so the way that Massdriver works is we allow operations teams, when they're packaging these IAC tools or IAC modules up and pushing them into our registry, to also customize the interface. Almost everything about Massdriver is customizable, from our type system to the UI. And what it allows you to do is expose that functionality, the kind of codified rules of your business, the standard security compliance of your business into the module, and then expose just enough config to the developers so they still have that control, right? I think that one of the things that's really interesting about platform engineering is when we actually get to a place where we're doing platform engineering well, the engineers using the product are doing DevOps, right? They're able to build and run things themselves. And so we allow operations teams to give as much control as they think their teams need. So if you want to allow your developers to pick the version of Postgres, great, you can expose it there. You can hide certain versions maybe that aren't supported anymore. Maybe you want to enforce that encryption's always on, so you don't expose it as a field to your developers. And so the operations team kind of has that control, and those source codes for those modules are just managed in Git or wherever they're managing them today. So if an engineer is looking at, let's say, a Postgres module in Massdriver and it doesn't have the functionality they need, they can always open a PR to their operation team and say, hey, I need this additional field, right? And I think that right there is important. Like, that is the collaboration of DevOps happening, right? Our teams need this full cycle of conversations to happen so that you're doing also good platform engineering, right? Like, the key here is that we're building a product internally. We need feedback from our customers. And to be able to open a pull request or an issue and say, hey, this module doesn't quite do what I need for this very specific use case, that's an important conversation to have. Maybe it's a one-off, but maybe there's a rule of your business that you've missed. And so that's kind of how the platform exposes it today. It's just push your modules into here, expose the UI to your engineers, and if your engineers need a change, you use the tools that your engineers know how to use to request those changes to the modules that your operations teams are publishing.
This is the gift and curse of Kubernetes in many ways. Kubernetes at the very bottom, as someone's done some work at the lower side of that stack, you can pick the nodes that you want. You can go with Ubuntu, Debian, Red Hat, whatever your choice is. And then Kubernetes turns that into a node. Doesn't really matter, but it turns it into a node in a way that no one has to think about the Linux distro. And sometimes we have purpose-built distros that are like read-only, can only run containers, or some are hyper-optimized for like machine learning. They got special hardware in there, NVIDIA, whatever. But Kubernetes says, look, you pick your node, we'll turn it into a node object and it gets registered, and then just people can use it. Or people don't have to use it, right? The scheduler can just pick which one for them. And the same is true of things like logs. You can use any logging daemon you want in the world of Kubernetes as long as it's compatible with the API. But in many ways, all of the stuff that you kind of see in that landscape, a lot of it can kind of get buried as implementation details. And then what you end up as Kubernetes is a platform for just like on the compute, storage, and maybe networking side. There's more to a platform than that. But Kubernetes does have this idea that You can plug in all of these things, and what you're doing is you're doing API design. So when I worked in GCP, Google Cloud Platform, a lot of the work with bringing a new cloud service to market. Let's say you wanted to bring Postgres to market, right? You want to call it Cloud SQL. So the first step is, number one, you figure out how to run Cloud SQL in an automated fashion so your users never have to. So that's kind of step one, and you figure that part out. And so once Postgres is running automatically under the hood, the job isn't done. You have to actually now create a control plane component. What is the API? Does G-Cloud work? Will Terraform work? What's the pricing model? And then you have to integrate with IAM, various billing systems, storage systems, encryption systems, you name it. But that's really what bringing a cloud service online looked like. You were designing an API, and everyone involved knew that's what you were doing. So when it got to the end customer, you do the same thing. So what Kubernetes is to storage, networking, and compute, I think Massdriver has been aiming to be that kind of API design point for all the other tools, Helm charts, Kubernetes YAML files, whatever thing you have that says these things need to be in place in order for our application to run and depend on other things to fulfill their promises. Database needs to be online. I need that IP address. I need that username and password plugged into this app in some way. Instead of doing that through 50 different tools, I think the goal of Massdriver has been to normalize all of those things to common API design. And so I think the missing part about DevOps was, yeah, it's cool if you work together and collaborate. It's cool if people build Jenkins pipelines, but where do you put the API once you do learn all of this stuff? And I think Kubernetes gave people a hint at that could be one of the places. But over time, I think configuration starts to dominate this discussion. And now we need to figure out where to put those. And I think that's what Massdriver has been doing. One thing I want to do now is bring up questions from the audience. I think Chip McIntosh, if you want to introduce yourself, make your statement or ask your question. You there, Chip?
I can actually introduce Chip. Chip's actually CIO of AMD Telemedicine. He's one of AMD Telemedicine's one of our earliest customers.
Oh, Chip, you there? I think Chip has a corporate NDA and he's not allowed to speak during that's that corporate firewall kicking in. No talking on Twitter Spaces. If you do have any questions, ask to be a speaker. We'll see that request and we'll bring you on. I think we have a, let's see. Yeah, I'm looking on the Twitter to see if there's any questions. I don't see any at the moment, but if you do have a question, welcome to the stage. All right, well, we'll keep it moving. So I guess maybe Chris, you can take this one. Where are we going? What's next here, right? So I've seen the tool. You had a pretty successful reInvent. I think a lot of people are really allergic to the buzzwords platform engineering. It's almost getting as dated as old as DevOps. People do not want to go through this fashion statement again. The LinkedIn profiles will get updated. I think people are really looking for like, what are we doing for real this time? And I think Chris, you just unmuted yourself. You want to jump in?
Sure, absolutely. Well, one of the things that particularly here as a company we're excited about, we're going to be sponsoring KubeCon Europe in Paris, and that's going to be in late March. And one of the things that we're going to be doing is KubeCon is all about the open source tools in the open source community, and so we have a set of tools that we're preparing, and we're going to be announcing over the coming months of tools that we've built internally to help us kind of build out Massdriver, but specifically around what we refer to as the bundles, which are the IAC, the Terraform, the Helm, the Pulumi, the CloudFormation. And so we're going to try to work with the CNCF to try to help establish some of the principles around what platform engineering looks like. In the previous conversations and talks that you and Corey and Dave gave, we talked about we don't want platform engineering to just become a rebranding of DevOps. And I think in order for that to happen, we have to build out the tools, and we have to build out these standards around what it actually means to achieve platform engineering. And so we've got some tools coming out, open source tools, and we're going to try to help establish some patterns around this is what it can look like to build tools, whether you're using it, using Massdriver, or whether you're building it yourself. Hopefully start kind of like what Kubernetes did with container orchestration, of establishing standards, convention over configuration, and see if we can really help drive platform engineering forward.
For a long time in the DevOps space, the saying was, it's not about the tools. And I think a lot of people neglected the tools, didn't invest in the tools or the skills necessary to even use the tools correctly. What do you think about that statement in this particular next kind of phase of what we're doing?
I'll be honest. I think the tools are required. I think part of the reason that one issue that we have, and Corey talked about this, you need culture, you need tools, you need experience. I think without the proper tools, any company that's going to try to push to accomplish the whole DevOps methodology is going to fall into everything we've been talking about. That's going to fall into setting up separate teams and building scripts and gluing these scripts together with more scripts. And I think DevOps itself came out with a lot of tools to solve individual problems. And Terraform for interacting with cloud APIs and declarative configuration, Helm for deploying into Kubernetes, but we haven't created really tools that sit on top of them. And I think the next step is we need to start building and investing in those tools, because I think we've reached about as far as we can go individually, solving individual problems, and we need to start building tools on top of what we have to automate the use of those. And I think without that, we're going to be stuck where we've been now for the last, 5 to 10 years.
Dave, you want to jump in?
Yeah, I mean, to add to that, if you think about like kind of the history of business on the internet, like once upon a time we were selling CDs from catalogs. And if you think about that time, you had a bunch of like unique business functions. You had like order takers, you had order processors, you had a billing department, you had a fulfillment department, and all of them had individual tools. The thing that allowed us to really scale that business was a little bit of software being the API layer in between. And I think like that's what platform engineering is. Like the tools are still important. How people work is still important. But a seamless communication layer allows us to go from hundreds of orders to like millions of orders a day.
I think that's dope. And, I think Chris mentioned experience. And there's this belief that when we say experience, you need to go do this by yourself from scratch. I remember being at CoreOS when Kubernetes came out. And I think for us, we were like, yo, we'll build something that's compatible and just share an API, because we kind of felt like, hey, we need to learn how to do this and have some agency over where CoreOS goes versus just adopting this new thing. And fair enough, it was so new at the time, it would have been irresponsible to adopt it as our default. And I think a lot of people in platform engineering, they believe that the only way to get experience is by rolling the thing yourself from scratch. And I think one way to get experience is when you do download, like if you're going to use a database, you can get some database experience building a database from scratch. You can totally do that. Or you can go download Postgres 14.6 and just get, decades of experience from a group of people who understand databases deeply, had problems in production, fixed them, and just made the results available for download from you. And I think that is also a form of experience, when you can actually download a product or service that actually has it baked in versus starting from scratch. Chip, I think you unmuted yourself. Are you back? Chip, you 0 for 2. we got to go with the strikeout at some point. All right, so at this point, with the last couple of minutes left, I want each of you, we'll go with Corey first, then Chris, then Dave. There are people probably in the audience right now that have made some progress in their career. Maybe they started out as Linux system administrators, They bought into the whole DevOps thing. They wrote more Terraform than you could imagine. And now they're looking at this platform engineering thing and saying, yo, here we go again. What guidance would you give to someone that does have experience managing systems? They're not idiots. They're just a little burnout with the tool sprawl and the buzzwords. What is their next step right now?
I think they have two very good choices ahead of them. And just for people who weren't on the stream earlier, I am the DevOps is bullshit guy. I'm the guy that wrote that. But I think the really important thing is I think the way that we've gone about it is problematic. I don't think the work or the people doing it are problematic. And I think that operations folk that know systems, they know networks, they know HCL, Terraform, like that is an immense skill set that is extremely valuable. And the idea that you have to become a platform engineer, you have to go and learn how to write some code too, I think is asking a lot of operations folk. Very much so, like asking developers to go learn how to do all this operations stuff is a lot to ask of developers. I think that our knowledge silos that DevOps is trying to tear down, I feel like we talk about them as silos so much that we kind of ignore the fact that they're expertise, right? And so I think as an operations person, I think you have to kind of follow your interest. Like, do you like the work you're doing now? Because you can easily fit in a platform team. Your skill set is actually very small. Go check the Stack Overflow surveys. There are not a lot of operations people on this planet compared to the number of people that have software development skills. You can keep doing what you're doing and have a big impact on your organization and platform teams. But if you're interested in becoming somebody who works on software, I think you just have to start get in and learning maybe Golang or something like that. Take the step to start learning to develop on the tools that you already know how to use, right? So if you know Terraform, but you haven't started maybe doing traditional programming languages, go learn Go and make some commits to Terraform or OpenTofu. We'd love to have you there. Right? I think that's a great path forward for those people that don't have development skills. But I think that the skill set that they have is very, very important, and we don't have enough of you. So it's my thoughts.
So what I heard there was, look, what you have is valuable. Don't let anyone tell you any different. But you also got to move up the stack. And moving up the stack means maybe learning the programming language that your tools are written in, so you can go from just being a consumer of those tools to someone who can help actually move things forward.
Yeah. And I think the only other thing that I would really think about is how can you turn your skill set into a product, right? Whether or not you can actually do all the development and the product management of that, that is the real key to making platform engineering successful in businesses, is starting to treat your operations expertise as a product you're trying to sell to your developers. So how do we get feedback and what can impact our teams and make them move fast and move the fastest quickly, right? So I think those are probably the two things I'd say to focus on.
If you've never worked in product before, the things that are really important here on the product side versus just automating things, that concept of a profit and loss. Is the thing I'm working on even profitable? What is the unit price for me managing this server versus renting one? What is the cost in terms of burden, in terms of people actually jumping on my platform and actually getting something done? You are somewhat in a competition with the alternative products that are out on the market, because that's how a developer looks at it. If I go and open a Jira ticket for a database and you tell me it's going to be 2 weeks, I am forced to go look at what a cloud provider provides and what their SLA would be. So I think if you're in a platform engineer, again, the key operative word here is platform, not automation engineer, not DevOps engineer. And the platform requires, I think, a product mindset. And so that means you need to be thinking about that user experience. And I'm not talking about the fluffy word user experience here. Use the tool, watch someone else use the tool, and if it sucks, you got to make it suck less over time. I'm going to bring it over to Chris to give us a little bit about what you think the next steps should be. Then I'm going to pause and take a question from the audience. Chris, your turn.
Sure. One thing I want to follow up a little bit, even also on what Corey said there, of the importance of the operations people that we do have, and Corey really talked about this in his talk, that the ratio of people with operation experience is actually shrinking, and this is where we really need to be able to leverage their experience and make a team of 1 feel like a team of 5, and a team of 5 feel like a team of 50. And I think this is the sort of mindset that I would encourage the people that want to move into platform engineering to consider. Is, what are the things that I'm doing that I'm doing repetitively that I can actually remove myself from the equation? Like, there's so much, speaking experientially, so much of the work that I've done as a DevOps engineer is repetitive. And if you're doing something repetitive, you should find ways to remove yourself from that equation. And we've done that. We've done that with scripts, but now we need to kind of move beyond that. And if I could encourage, if there's any, not just developers, but managers or business owners that are looking at platform engineering and considering moving in that direction, one thing to understand is, if you're going down this path, if you don't want this to just be the same thing that's happened with DevOps, where you rebrand and you have the same struggles that you had previously, you really do need to look at this in terms of your company as a new product that you are building to serve your development teams. And I think one issue that companies may run into is, if they're not over a certain scale, they may have issue finding the right amount of talent, knowledge, budget to really be able to build effectively 2 products: your core product, and then an internal product that you use to serve the developers and enable them. And so this is also part of the reason that we built Massdriver, is we want to give a buy option and not just a build option to all of these companies, because you don't see as much of these problems when you get to FANG and these massive companies that actually do have the budget to be able to build and sustain and an actual platform team. And so it kind of is both sides. DevOps engineers, start looking at how you can automate and start putting your expertise into a way that's consumable by developers without you being involved. And organizations, be prepared. If you really want to take this path and you want to build, you're going to need to invest in it. And if you don't want to build and you want to buy, then maybe take a look at Massdriver.
I want to be super clear here too, because we've seen some really great examples over the previous set of decades. I think what Netflix did for the industry, they built Spinnaker, their CI/CD tool, and they turned it into a product internally, but they also turned it into a product externally. So a lot of people probably use Spinnaker as their CI/CD solution or their CD solution for their own needs, and they had lots of tools like this, Eureka, plenty of things. There's been platform companies like HashiCorp that have come around that build things like Console, Nomad, Terraform, Packer for building AMI images. And when you look at a tool like Packer, back in the day, Packer would have been a shell script for a lot of people, right? You would have wrote a little tool that made machine images for you, and you'd have been the only team that used it. Probably no documentation, no API, no cool logo, none of that. But when you take it to the platform level, that's how you end up with a tool like Packer, right? It doesn't have to be the biggest money maker in the world. It doesn't have to be the thing that changes the game. But it's like a good example of what happens when you productize something so that other people can consume it. Documentation, API, command line tools, user experience. You got to put a little thought into it. And I think that's really what we're talking about here. And this decision goes for every layer of the stack. Most people are not interested in building their own networking gear. So you buy that and you just use it. But as you go up the stack, especially when you start to get to the software side of things, there's something about software and overconfidence. When people think they can build it in software, for some reason they do. But you also are still making that same buy versus build. So you may decide to buy your Kubernetes, but build your own experience layer on top. And I think Massdriver comes in and says, well, maybe everyone shouldn't be forced to build their own experience layer on top. Maybe there should be buy options there that are not Heroku clone like past tools. Before I go to Dave to give us the last next step piece, there was a question that came in through Twitter, and I asked Bro Nifty to join in as a speaker so he could ask the question directly. So Bro Nifty, if you could unmute yourself, introduce yourself, and ask your question.
Yes, thank you, Kelsey. Hi, Brother Nifty. And quick question was just when Kelsey was explaining about how another tool, Cloud Foundry, works great for the templates, but you can't extend it if it doesn't fit neatly within their packaged pre-fabricated solution. Yeah, I had the same kind of issues. I'm working with CDK for Terraform and solutions that integrate an abstraction over SDKs. So work with the objects in AWS, GCP, Azure, like you add a file to a bucket and so on and so forth, and also provision the bucket as well. It's the same Wingling. And but it compiles to Terraform. And I see that in Massdriver, I got this installed and kind of did a little example, and it looks like the code is actually Terraform you're using, or the open source version of that. So I guess my question was, as long as it looks like you've got like some diagramming here to keep, kind of like, I don't know if it's called diagram as code or you just diagram the code so it keep it of it like
I
easy
think
to
one of the
manage.
questions you had was, you're invested in CDK, right? Which is maybe a little bit more specific to Amazon side of the house, and you're not really looking to redo everything. And for you, it's like, hey, that would be an uphill battle. Maybe someone from the Massdriver team can talk a little bit about the differences between that UI experience that you just talked about. Looks like it's drag and drop. There's some lines you can draw versus like that hardcore stuff underneath. In this case, CDK. Number one, what's the compatibility with CDK? Number two, what's the relationship between the UI side of the CDK at the bottom?
Yeah, I think I can jump in here. So those boxes that you're seeing in the diagram, those are the boxes that power Massdriver today. But what powers Massdriver isn't going to power your business. You have security and compliance differences between what we do and what you do. And so it's really important for the Massdriver team to be able to support any of the IAC tools that you want to use. So this week on our blog, we actually published a lot of information about our bundle spec. And all that is a wrapper around your existing tooling, which allows you to create interfaces in Massdriver and transfer data between your tooling. So whether it's a bash script or a Python script, whether it's CDK, whether it's Helm, our provisioner can make sure that your tooling speaks JSON and can communicate to each other. So those boxes are all yours with whatever tooling you want. And the consumption mechanism for your end user, the engineers, is exactly the same no matter what.
Yeah, the way it works, there's essentially that what you're seeing on the side is a registry. We have an IAC agnostic registry, so it can hold Terraform, OpenTofu, Helm, etc. And as your engineers diagram, it's pulling those modules out of the registry and then doing the provisioning. So your engineers are able to design the platform that they need based off of the codified rules of your business and the cloud services that your operations team said that your org supports by pushing them into the registry.
I know this isn't the perfect description of the product, but I remember the first time when I learned like Ruby is on Rail and just a tad bit of front end. I had all these scripts to automate things, and it was weird because most people are like, I don't want to install this command line tool on my laptop. I didn't package it so it could easily be installed. I didn't think about dependencies. And I remember for the first time, this was like 2007, and I put it all behind these Ruby on Rail apps. And you just went to one web page, and there's like a little form, right, that stood in place of the command line flags. And you can just type in stuff from a drop down and hit enter, and all the logs would just go in your face. And one thing that I thought was super powerful about that, in some cases, I was using Puppet under the hood. In some cases, it was just some script that the team was used to running. But either way, everyone felt like it was way more accessible because they just go fill out a form and hit enter, and then things would happen. I'm not saying it was the best product in the world, but it was like the first time where I felt like I could actually up level who could use my scripts and tools without having to teach them the whole tool first. So I think in the case of the design of Massdriver, it's very similar. These tools are all super powerful. I don't think anyone just aiming to replace them or thinking that they can make one tool that makes it effective for everyone, you're going to lose that battle. So just like restaurants, there's going to be lots of tools for different reasons. But the thing I do like, same thing that makes me like Kubernetes, you can bring the things you need at the bottom and give a consistent API at the top. And I think that's the real traction. With that, I'm going to pivot up to Dave before we wrap up. Dave, good conversation for the last hour. A lot of people in the audience are like, hey, this sounds good to me. I'm ready to really kind of fulfill the promises of DevOps. I don't want platform engineering to be another buzzword. How do I just take the skills that I have, system administration skills? I learned all of these tools. I can automate anything you point me at. What is the next step I need to take to make this platform engineering thing a real thing?
Yeah, I think Chris and Corey covered the why pretty well, the how pretty well, which is you got to learn some software. You got to learn some software fundamentals. You got to learn how to write a language, probably something compiled to binary, right? Like Go, probably something that can serve the web, like a Ruby on Rails, an Elixir, something like that. But for me, I'm kind of like, I'm less interested in the how, because I think how is how we got into this problem. I think why is like the important question. And I think like as you start that platform engineering journey, like informing yourself of the why is going to give you that product mindset. And like for me personally, the why is context, right? If you use one tool to design, to manage, and to observe your cloud, you now have a ton of information which can be communicated to anybody in your organization really, really easily. I believe that DevOps is the kind of conveyor belt of your organization. Conveyor belts are important. They keep the operation going. And I think the more tooling you can put in place that helps eliminate breakdowns, that helps diagnose issues, like the better your organization is going to run. And I feel like sitting from the DevOps side, no product person ever gave me a high five for getting a database into production. With platform engineering, your kind of knowledge of backend systems, of the cloud, of Kubernetes, all that stuff can now like pay off to the organization, can move faster and tangibly add value. And I think like that should be something that really excites you if you're kind of burnt out in kind of the DevOps loop.
Well said. I mean, look, I want to appreciate the whole Massdriver team for showing up with us today. Thank you for all the questions. I think the big thing that I think the real moment here is that a lot of people have these skills. These skills are actually getting a little bit more valuable over time. A lot of people think that these skills are probably dead and gone, but trust me, there are people writing Fortran and COBOL right now, probably making $400, $600 an hour. Because when these skills become this scarce, the value tends to go up. But also, I want people to understand that these skills will always be needed. I know a lot of people are predicting that the cloud will take over everything. I used to work at a cloud provider. I promise you, when you adopt the cloud, there's probably going to be even more work to do because of all the miniature platforms that are baked in. You're going to have to build that experience layer on top. All the skills you already have are super valuable. The question is, how does that value get turned into a multiple that actually makes it easier for people to do their jobs? DevOps introduced this concept to people that silos were bad. That's something I kind of disagree with in many ways. If you want to scale something, you have to be able to produce products, in this case, infrastructure, that allows other people to use said infrastructure without becoming an expert first. And in many ways, if you squint, that looks like a silo, and it's not a bad thing. Silos are only bad when there's no API between the groups. And I think what we've been asking people all day for the last hour is you need to figure out what the API will be between what you do and what people are trying to do. And that's when you take all the tools, CDK from Amazon, Terraform from HashiCorp, Helm chart from the Kubernetes community. And if you push all that stuff together and you ask yourself, what are people actually trying to do with these individual tools and puzzle pieces? And if you do a good job, then you'll be the person that gives people the big picture so they know where the pieces go. So what API are you building? And I think platform engineering, we should actually think about what a product that you're trying to deliver. Buy versus build is a new question you can ask, even above the low level details, and start thinking about the experience you want to really put out there for you and your team. With that, thanks you all for hanging out with us. The space is recorded, so you can share the link with other people, and we'll catch you next time.
Awesome, Kelsey. Thanks so much for co-hosting, and We really appreciate that. For anybody who's still listening, we are still streaming our Massdriver Day. I dropped a link in the comments. Chris is going to be doing a talk on a day in the life of DevOps and platform engineering in just a few minutes. Thanks so much, everyone.
Hey everybody, Chris is going to be joining in just a few minutes to talk about a day in the life of DevOps and platform engineering. Really appreciate everybody joining today. I hope that the audio quality from Spaces was fine through StreamYard. Okie doke, let's bring on Chris. I seem to be having a little bit of trouble. Give me 1 second, everybody. Sorry about that.
All right. Welcome, everybody. Thank you for joining. My name is Chris Hill. You just saw me in the last session. I'm one of the co-founders here at Massdriver, and this session is going to be a little different than the ones that you've had previously. Instead of giving a speech here, I want to give you actually a demo of Massdriver, and I want to use it as an opportunity to compare it against the daily grind that I think most people, most DevOps practitioners encounter in the world of attempting to achieve DevOps at all of our organizations. And I hope in doing so to give you a glimpse into how Massdriver might be able to help your organization move into platform engineering and really capitalize on the benefits of it. Now, before I get started, I will say that we do have team members in the chat, so feel free to ask any questions. I'm not going to be stopping to address them. I'm going to move forward, but we will address any questions you have in the chat, so feel free to ask them. Before we actually start with the demo, let me give you a brief background about myself. So I've been doing cloud operations work close to a decade. And what I've found is most people in operations come from one of two ways. Either they were a sysadmin that was working in a data center and the company decided to move to the cloud, and they either had to learn or there weren't enough sysadmin jobs. And so they learned they had to figure out the cloud to be able to work. The other side of it is the software side, being a developer and being on a team that needs to run in the cloud, and you get selected, and now it's your job to go learn how to deploy into the cloud. So I came from the second school. I was originally a developer. And what this means is that I've actually seen both sides of DevOps. I've seen being a developer, I've seen being blocked and having to wait for the cloud things. And I've also been an operations engineer, and I've seen the tedium, the difficulty of that. And usually companies are going to approach DevOps in one of two ways. Either they create a team that they call the DevOps team, which isn't really DevOps. It usually turns into ticket ops, is what I like to call it. And we'll talk a little bit more about that. But one of the issues with this setup is that the team that maintains your infrastructure is not the same as the team that uses the infrastructure. And this separation can create misaligned priorities, communication and productivity barriers, and I've seen it lead to frustration, animosity between the teams. And that's a difficult thing to get over. The other side of it is DevOps means everybody does it. Developers have to own the running and operation of their code. And unfortunately, this, I think, generally leads to wasting valuable dev resources. You want your developers, particularly your best developers, focusing on producing as much code related to the product as they possibly can, not learning how to use the dozen or 24 tools that it takes to stand up and run your infrastructure. And so I've been in both of these scenarios. And when Corey and Dave first came to me and were talking to me about the idea of Massdriver, I'll admit I was skeptical. And part of it was because I had seen all the different ways that DevOps had failed. And I thought that this problem was too complex and too nuanced to simply be automated away with a platform. And I found out that I'm wrong. And I really do think that platform engineering is the answer to a lot of the pains that companies are experiencing with DevOps. And what I like to say is that as an industry, in all industries, when we face problems, we solve it with people until we can solve it with technology. And I think DevOps arose out of problems that were arising in the managing and deploying of software. But so we fixed those by using technology, but all that technology now has created a new set of problems. And so I think this is where it's now time for platform engineering to take over and to allow platform engineering to be the technology that solves the problems that DevOps created. And so with that, let's jump in. So first thing we're going to talk about here is ticket ops. And this is exactly what I mean by ticket ops. This is a day in the life of a DevOps engineer, is waking up or getting to work or after lunch, getting a message and being told that there's yet another ticket that you have to deal with. This is what has driven my work for the last decade. Another ticket, another service, another update. You know, maybe it's a database, maybe it's an S3 bucket, maybe it's an IAM configuration. Today it's developers, tomorrow it's from the security team, the next day it's from the finance team. It just felt like all I was doing was chasing an endless pile of tickets. It didn't feel like I was actually impacting the business. A lot of what I was building was just scripts and tools to make my job easier, not necessarily things to make the business better or more productive. And so some ways I felt like Bill Murray in Groundhog Day. And this is ChatGPT's best attempt at portraying Bill Murray working on his laptop in the diner, if you've seen the movie. I felt like every day I was doing the same sort of work, the same requests, the same changes. I was copying and pasting YAML. I was copying and pasting HCL and Terraform. I was copying and pasting JSON. And in doing all of it, of course, it always has to be done urgently. It needs to be done yesterday, but it also needs to be done securely. We can't violate compliance. And we need to make sure we set up monitoring. And by the way, when you set up monitoring, make sure you set it up so that you're the one that gets woken up at 2 a.m. when something breaks. And this was just, it wasn't enjoyable, it wasn't fulfilling, and it didn't feel like I was having the impact that I wanted to have. And so I'm going to take this example right here, and we're going to use this as an opportunity to dig into how does this look as a normal, DevOps engineer, and how could this look at a company that was using Massdriver to achieve platform engineering. And so let's dig into the process of standing up a new database for whatever this new project is, and seeing how it looks in DevOps and in platform engineering. So it's going to be a lot of code, a lot of time in Massdriver, and a lot of looking in the AWS console. So here we have ourselves a Terraform module, and it's nothing special. It's specifically for AWS RDS. This Terraform was written by us, I don't know, last year sometime. We're not going to dig into the Terraform itself here. I'll also make it a little bit bigger if I can. There we go. We're not going to dig into the Terraform itself, not because Terraform is trivial. It most certainly is not, but that isn't the focus. This isn't a demo of Terraform. Realistically, you could use any IAC here. You could use Pulumi, you could use Helm. In this case, we're going to be using Terraform. So the first thing with this module that we're going to do is jump in and take a look at the variables. Let's see what we have to figure out just to be able to deploy this thing. Let's take a look at variables.tf. And all things considered, this isn't that bad. We've got a handful of configuration variables, backup database, observability, storage. What may look a little strange here is that these are structured fields. We'll get into why they're structured. It's going to become apparent here in just a few minutes, but just accept the fact that they're structured fields right now. There's 20 of them, and if you read the names of the fields, you can see why it's so burdensome, I would say, not just even for developers, but even for operations engineers, to try to figure out which of these variables are important and which ones aren't. It takes a lot to write one of these, and you learn a lot when writing. Which of these fields are necessary, which ones aren't, which values or which of these are associated with security, which ones for performance, which ones are dependent on each other, which ones, if you change, cause a destroy and a recreate. There's a lot of complexity just in these variables, and there's only about 20 of them here. If you go to the official RDS, or I think it's an Aurora module, there's 121 inputs. And so this is a far cry from that. And so when you're writing this Terraform, there's a lot of docs you have to read, and creating all of this config. And the problem is that doesn't always get captured. We could have descriptions and we could set some defaults here, but when you have to redeploy this 6 months from now, you're still going to have to dig back in and figure out which of these things should we be configuring, which ones can be left as default. And so that alone is just a huge time sink, and it's a barrier to developers being able to come in and execute and run this Terraform, because we shouldn't be burdening them with learning all of this stuff. They should just be able to get the database that they need. So seeing all of this here, we need to actually hydrate these values. And unfortunately, you'll see we got nothing. So I'm going to do the standard DevOps thing, and I'm going to copy paste a config from something else. So while I'm copy pasting this over, what I want to say is I hope through everything I'm going to demonstrate today, I actually want you to kind of keep track of how often I'm saying copy paste, because so much of our work is just copy pasting, and our jobs should be more than that. We should be automating away the copying and pasting, but I digress. So we have a set of config. This actually, we're going to say, came from a existing database, so we're able to just copy paste it in. However, we're missing two very important values: the VPC ID and the subnets to deploy into. These are what I'm going to refer to as dependencies. This RDS database actually depends on another piece of infrastructure that was probably also configured and provisioned with Terraform. Now, getting these values in programmatically, it's not always immediately easy. Terraform, if you're all in Terraform, it offers a couple solutions. One, you can run a monolithic module. You could put everything in together. I don't recommend that, because then what you're doing is you're unifying the life cycle of disparate resources. Your network has the same life cycle now as your database and anything else that is in that module. And that's not what you want, I hope. Your networks likely should be persisting longer than the things that are existing within it. You could use remote state to go in and secretly fetch and pull the values out from wherever you ran, wherever the state is for your network. But I don't recommend that because, in my opinion, remote state just makes your Terraform a hidden monolith. You are still creating dependencies. You're just not documenting those dependencies in the code. And if somebody comes in and redeploys the VPC, they may actually break multiple other modules without knowing. And more than that, the configuration might be stale. You don't want to reference the states. You want to get live values for what's going on. And so I don't recommend using state. This, by the way, only compounds when you're moving between IAC tools. If this was going from, let's just say, Pulumi to Terraform, now you have no recourse besides the true DevOps way, which is to copy paste the values. And so what we're going to do is we're going to head into the AWS console, and we're going to copy paste the values that we need into this config. So let's head to the console. Let's head to VPC. Let's say that we're just going to deploy into this top network right here, which happens to be my own test network. So let's copy this VPC ID right here, and let's head back into the code and let's paste it. Here we go. For subnets, this is going to be a set of strings. And so let's head back in, and now we have to select the subnets. Let's head to subnets. We're going to filter by the VPC. And here we encounter yet another barrier to us really allowing or simplifying the deployment of this database. We have 9 subnets here. And some of them are public, some of them are private, some of them are internal, as we call them. And so we shouldn't be burdening developers with having to know and understand the network topography. And so it's on now operation engineers to know which subnets to be deploying into. And I can tell you, we should be deploying into private or internal subnets. So I'm just going to be taking the private subnets. I'm going to be copy pasting them over. One by one, all 3 of them. Such is the life of a DevOps engineer. And one more. Right here. Okay. We now have the 3 subnets. This should actually be ready to deploy. And I have tested it. It is ready to deploy at this point. But let's just take this example of what we just done right here of a Terraform module hydrated with config. And let's see what this process would look like in Massdriver. So if we jump back over to our console, we're going to head into Massdriver, which I've got run right here. I've got a blank canvas. And so let's say we need an RDS database. We're going to open the bundle sidebar. We're going to search for RDS Postgres. I'm going to pull this onto the canvas. We'll name it RDS. And this is one of the coolest parts right here is we can automatically detect the dependencies of our RDS database, which happens to be an AWS VPC, and we can already add it onto the canvas. This already shows the power of a platform. We can detect and fulfill contracts of dependencies. And more than that, we can make sure that instead of having to copy and paste the config between the VPC and the RDS cluster, we can actually reference an existing VPC that's already been provisioned within Massdriver and say, hey, use that existing VPC. This actually allows us to have different governance models. You could say the operations team deploys, manages, configures our networks. Our developers can't, but they can deploy into our networks. They can create resources in them. So this allows you to set up governance however you want within your organization. Additionally, we're able to pass information about this VPC, such as the VPC ID, as well as the 3 types of subnets, public, private, internal, and all the information about them, so that when this RDS bundle, which just happens to be Terraform, is deploying, it can pull those values in dynamically, no copy paste necessary. So let's look at configuring this RDS module. If we open up the config plane, what you're going to see, hopefully now it becomes clear exactly why all those fields in the Terraform were structured. You'll notice that they end up mapping 1-to-1 with the variables that we had in the raw Terraform. And it's actually because that Terraform is actually the Terraform for this bundle right here. I just copy pasted that for the use of this demo. And so the variables are all the same. Now, the big difference is instead of just being raw fields that you have to figure out, we can create a rich UI for configuring these variables. And this UI also is compatible, not just with Terraform, but with Helm, with CloudFormation, with whatever tool that you want to use to deploy. So this allows you now when building bundles out of your Terraform to actually focus on how you can enable developers and unblock them. Which of these fields should be configurable? Should they be able to use version 4.3 or any of these? Do you have a policy at your company that's only Postgres, version 14 and up? You can create these enums. You can list out which of these instances should you be able to deploy to. You can expose certain variables that you want them to configure, and you can hide the ones that they shouldn't be able to change. You can create conditional fields, such as if you set provisioned IOPS, you have to specify the IOPS. Otherwise, if you're using GP2, you don't have to specify it at all. You can specify which fields are immutable. So after it deploys, you can't change it anymore. And this will prevent accidentally changing a field that could cause disruption. And one of the coolest parts is you can actually create a preset or a set of presets to guide your developers the way that they should be deploying this. So in this example, we have a development preset and a production preset. Let's select the production preset. We're not going to deploy yet. We're just going to save. So that configuration is now saved. Before we deploy, we're actually going to jump back into Terraform and we're going to talk about what it looks like to attempt to deploy the Terraform code before we come back here. So let's get back into the code. So when executing Terraform, the first question is going to be like, where are you going to do it? You shouldn't be doing it locally. There's security issues. One, you need local credentials. And probably the bigger one is there's no auditing of the changes that you're making. You could be changing production locally, and somebody else actually could be changing production locally at the same time, especially if you don't have state locking. You may forget to check those changes in, and somebody else may make a change, and now you have diverged state. So don't deploy your Terraform locally. You want to deploy it as a part of automation. The other part is, what are you going to do with state? You also shouldn't be storing state locally. Ideally, you're using some form of remote state like S3. In this case, we're just going to assume that we're doing state locally because, again, this is not a Terraform workshop. This is a DevOps demonstration compared to platform engineering. So what we're going to do instead is, once again, the DevOps way. I happen to have a set of GitHub actions that allow us to deploy into, or deploy from GitHub Actions into into AWS, into wherever we need to deploy. So I'm going to copy the directory, actually copy -r, GitHub into this directory. Let's go back into the code and let's take a look. Here it is right here. There's 2 steps, validate and apply. I'm not going to dig into this because this also isn't a CI/CD. Counterintuitively, we're not going to be going over CI/CD too much in this. But what I do want to point out is, once again, all I've done is copy pasted this config. I would have to copy paste it everywhere that I go. And this is not what we should be spending our time doing. Copy pasting this config place to place. I'm also really trivializing the amount of work that went into creating this thing. It was not trivial to create this and test it and get it working. So let's commit this and move on. So we will do git status. Let's git checkout and say add CI pipelines. We will git stage, or git add, I'll say, .github. And it's also stage those variables that we just modified. And let's git commit. Well, also we should get the, we'll deal with the Terraform lock later. Git commit, message, added CI pipelines, and we will git push. We'll figure out merging and putting all that in later, but this is what it looks like to deploy Terraform. Now, you may be using something like HashiCorp or Terraform Cloud or things like that. That's fine. That solves this problem potentially for Terraform, but it doesn't solve it for all of the other tools that you may be potentially using. And it's just yet another tool to the DevOps toolkit. So let's see what deploying looks like in Massdriver and see if we can make this a little bit easier. So let's hop back into Massdriver here. We'll open RDS and we click deploy. That's it. Something to notice now, everything that we've done thus far didn't have to be done by an operations engineer. Like, a developer could have done this. A developer could have dragged the RDS bundle onto the canvas, could have configured the VPC that was existing, could have selected the development preset, and could have clicked deploy. An ops person didn't need to do all of the work that we just did, which I honestly breezed through. This is where we're trying to get to. We've removed the barriers for developers to be able to execute your Terraform. That's a win. We've implemented guardrails around the configs to prevent them from setting misconfigured values. We've programmatically specified dependencies, making it very easy to see what needs to exist before you can deploy. Excuse me. And we've handled deployment and state management for the developers. They don't have to be burdened with figuring that out. You're seeing all of the resources that are being provisioned by Terraform and coming back through. They're going to be stored by our system. We're going to keep record of them. You're going to have what we call an infrastructure bill of materials, outlining all of the things that were deployed as a part of creating this RDS database. This is a huge win. So now that we've deployed this RDS database, which, by the way, it's going to take about 9 minutes. Let's click out of it. Now let's talk about, well, we've made this, let's say, in staging. We've proved that the database works. We need to promote to production. What is that going to look like in day of the life of a DevOps engineer? Well, how are you going to do that in Terraform? Now, again, this may actually be solved with some other tool that you have. But based on how we just did it, that CI pipeline isn't set up to be able to deploy to staging and production. So we either need to redesign that workflow using GitOps, maybe merges to a staging branch, deploy to staging, merges to a prod or main branch, go to production. Maybe we copy pasta the whole Terraform module because maybe the configs need to be different. This parity has consistently been a difficulty for operations teams and for developers. And so I'm not even going to get into what that could look like because you don't need to see me copy, paste, and tweak things again. You understand that? Let's stay in Massdriver. Let's take a look at what it would look like to go to production with just this config we have right here using Massdriver. So up here in the top, you'll see that we have webinar and staging. Webinar is going to be the project. That's effectively the set of bundles that we have and the connections between them. We've kind of abstracted that and said these things connected together as a project. Staging is the environment. An environment is going to be, you could say, an instance of this environment right here, of these bundles. And so we can create multiple environments. We have a staging one. Let's say we wanted to go to production. You just click this. We say production. We will abbreviate it to prod. This is where you can deploy to whatever set of credentials you want to deploy to. In this case, the only AWS credentials I have are the same ones. I wouldn't recommend deploying staging and production to the same account. But for this demo, we'll at least configure it that way. If we jump over now, we're in the production environment. One thing you'll notice is RDS is no longer initializing and the VPC is no longer a remote reference. This is a different environment. Massdriver is enforcing the fact that a VPC and an RDS have to be here because in every environment, you need the same bundles. We are enforcing parity that way. But you can configure these differently. You could actually deploy this VPC if you wanted to. Or you could reference the same one, or you could reference a different VPC. For RDS, you can configure it differently. Let's say we want to actually use production configuration. Let's save it. We won't deploy. But what we can do is compare the two environments. Let's see what the difference is between our staging environment and our production environment. And now we get a list of the configuration values with the differences highlighted. If we were to try, or if I were to try to show you what this looks like in standard DevOps world, it's going to be digging through Git configs and diffing branches, and it's going to be a mess. Instead, in the very same tool where you are configuring and deploying, you can see the differences between your environments and potentially even identify misconfigurations between environments and triage right here. So on the topic of triaging, let's jump into metrics. We've deployed, we've configured, we've deployed our database. Next up, we need to actually start monitoring it. So a day in the life of DevOps, when it comes to metrics, you're probably looking at one of two things. Either getting metrics where they need to be, such as into Datadog, or building the dashboards that you're going to have to look at when you're paged at 2 a.m. So to keep things simple, we're not going to go into Datadog. We're just going to continue to build on top of what's already in AWS with AWS CloudWatch. So let's jump into AWS CloudWatch and see what we can do there. AWS CloudWatch, there it is. And CloudWatch already has dashboards. And let's go to automatic dashboards. And they even already have an RDS dashboard. Look at that. Our job is done for us. We can check that off the list. We have the RDS dashboard that gives you seemingly everything you could ever want to know about the RDS instances that are running in your account. However, there's crucial information that's missing on this dashboard that you're going to really wish you had when you get paged at 2 a.m. And that is that databases don't really misbehave. You rarely see a database go from a healthy state to an unhealthy state with nothing externally happening to it. Changes to systems are what trigger alarms. Changes to the database or changes to the systems that connect to and affect that database. And so let me ask you, where is that on this dashboard? It's nowhere. It's nowhere on any dashboards. It's not in Datadog. It's not in CloudWatch. And I think this is a real miss that we have in how DevOps generally approaches the concept of observability, is these dashboards don't have context. They tell you various states of the system, but they don't tell you how systems have changed, when they've changed, what changed, and where they exist in the greater infrastructure map, in network diagram. And so this is not going to be very useful at 2 a.m. And in fact, you may notice there's an alarm going off. So tell me, looking at this dashboard, how useful is it in telling you what the alarm is that's going off? It's mostly useless. We can go, let's look at the alarms that are in alarm. It happens to be a database connection being greater than 20 for 5 minutes. And we can go in and look at the dashboard. Let me go back here and see if this can help at all. But instead, let's actually jump into Massdriver, because that database is being managed by Massdriver right now. And let's see what it looks like to investigate and try to triage this issue in Massdriver. So here it is right here. Let me ask you, which would you rather see at 2 a.m. when you have to wake up and triage this issue? All of those graphs that you have to decipher, or an infrastructure diagram, an indicator of which piece of infrastructure is failing. When you click on it, an alarm telling you exactly what is going wrong with it, and the diagram showing the context of where this piece of infrastructure exists in the context of the system. Because now what we can do is say, well, what has happened to this system? We can check the deployment history of the database itself, and nothing's happened for the last 7 hours to the database, which means it's unlikely that this has anything to do with a configuration change to the database. The other thing we have here is a line indicating that this worker application is connected to the database. If we click on that, we can notice we've actually had multiple deploys to this application over the last 7 hours. So let's dig in and take a look at what change occurred last in this system. If we compare, the configuration change was setting the workers count from 10 to 50. Now, if these workers are connecting to the database, it's very likely that this is the sort of change that could impact the number of connections going into the database. We were able to identify and triage this issue immediately because we had the context of where this database exists in the greater system and the pieces that depend on it. So let's head over to the configuration. Let's update the number of workers back to 10, what it was before. Let's click deploy. And let's go back to bed. How about that? So one thing I want to point out here that may have been a little bit subtle is I just altered the configuration of a custom application using the same UI that I used previously when modifying the database. And so let's take a moment and let's talk about, how do you do configuration management for your applications? I'm not even going to try to do a demonstration of it because I can't even venture a guess. If there's CI configs, maybe you're pulling from a system like Console, maybe you're just baking it into your applications, maybe you have config files that you store alongside your applications and you deploy them in. I don't know. But is it that simple to make configuration changes? And by the way, our alarm just went away. We're able to triage it that quickly. What I'm trying to point out is that not only is this whole UI configurable, but you can actually make your application itself, custom application, configurable from this UI. We're able to add a field for the number of workers. And from this ends up getting passed to Terraform or whatever system you're using to provision, maybe Helm, as a JSON blob. you can extract the values out and inject them however needed. So you can inject them in as environment variables. So this, not only that, you can actually, within this config, you can put minimum values, maximum values. I could update this and say, you know what, you can never set any more than 20 workers, and that will prevent this error from ever happening again. While we're looking at this, you may also notice that when we scroll back through here, there's nothing in here to configure RDS and the connection to RDS, yet it is connecting to RDS. How is that happening? Once again, this is the magic of these lines. Not only are they a visual representation of the dependencies and the connections between the pieces of your infrastructure, they also allow us to pass information. So the same way that the VPC was able to pass information such as the VPC ID and the subnet IDs into RDS when it provisions, RDS is able to pass Postgres data into the application when the application is configuring. So things like hostname, username, port, and password are available in a JSON blob when the application is deploying. This makes your application config portable. Any Postgres database that fits that pattern will be able to, your application will be able to deploy and connect to. It also prevents you from having to do secrets management. So let's also talk secrets management. How are you handling secrets in your environment right now? Are you using Vault? Are you using SSM? Hopefully you're not storing them in plain text in Git, or if you are storing them in Git, hopefully you're at least encrypting them. Even if you're using an industry standard like Vault, there still is having to copy paste the values that come out of Terraform. Here, I'll show you. In this Terraform, we have outputs to output the username, password, hostname, and port. These are the values that we need. But even if this ran, I would have to copy paste these values out of GitHub Actions. I would need to auth into Vault. I'd need to upload these secrets. I'd need to figure out how to get credentials into my applications so that they can fetch those secrets and configure themselves with environment variables. That's a lot of work. It's a lot of copying and pasting. I know because I've set up Vault and I've run it in multiple companies. And this system in Massdriver is a lot easier. Dynamic secrets, encrypted, injected at runtime, and no human ever has to touch it. This is the power of a platform. So there's one more topic I want to talk to you about before we close out, and that is costs. You may remember one of the things that was asked for was a cost estimate. And so let's take a look at how most engineers view costs, particularly in AWS. Let's go to the billing dashboard. Actually, it's not billing. There it is. It's cost. What's it? Cost Explorer. Here it is. And here is the visibility that most DevOps engineers have into costs. This is day in the life of DevOps right here. To be clear, I'm actually an administrator. I have admin access to this account, and I still have no visibility. This is a weird AWS thing of their permissions and at the organization level. Now, this is a bit tongue-in-cheek. It's a bit of a joke. I have peered behind Cost Explorer. I didn't put all of the things together here, and I could have to demonstrate to you what it looks like in Cost Explorer. But what I can say is, even if you have access to Cost Explorer, it's extremely tedious and takes a lot of work to get it to actually start helping you. You need to tag all of your resources that you want to be able to detect. You need to set up billing on those, or billing analysis on of those tags. You need to constantly be keeping it up to date. It takes a lot of time and investment to be able to figure out how much money you're spending in AWS. Secret, it's a lot, and perhaps that's intentional why they don't make it easier to see all of these costs. Now, you could look into tools like InfoCost Advantage, and those tools can help in terms of getting you visibility into your costs. However, day in the life of DevOps, most DevOps engineers aren't going to necessarily have access to Vantage or InfoCost. And even if they do, it's not a part of their normal workflow. It's something you have to go outside of it to use and to see. And one of the things that we did in Massdriver was bring costs to the forefront. We want you to be able to see the costs of your environment on each individual piece of your environment, and rolled up at the environment, and rolled up at the project level. We want billing and cost management to be a proactive, something you do proactively and not reactively. You don't just go into Vantage and say, we spent way too much, let's figure out where it's coming from. You can immediately see where your money is going and how much things are costing you, and how the changes that you're making are affecting the costs. And this is what allows you to now have some degree of ownership and agency in helping your organization control costs. So there it is. We've covered configuring, deploying. We've gone into observability and metrics, change management, secrets, and costs. Let's kind of close this out. So let's jump in back into the slides, and let me recap here. In order for us to move the industry forward, DevOps has to move beyond ticket ops. And without a platform, DevOps almost always is going to fall into ticket ops. You're going to continually be burdened by developers, security, the finance team. And I'm not saying this to criticize or dog on them. They are the customers. They are who we're supposed to serve as operations engineers. But we need to figure out how to leverage the expertise that we have in a scalable way. And the way that we do that is by automating the automation. We have to move beyond copy pasting configs, IAC, permissions, pipelines. We need to build that automation into our automation. We need to be able to leverage technology to make our jobs easier and scale our expertise and our knowledge. We need to give developers the ability to get what they need when they need it, without burdening them with learning all of these tools or creating risk to the business through misconfiguration. And you can multiply your efforts by investing in a platform. If you start putting your Terraform into the platform in a way that your developers can use it when they need it, you're going to feel like a single operations engineer is operating like 5-10 operations engineers. I can tell you, I built a single S3 bucket bundle, and we're probably running at least a dozen of them. And I've deployed, I think, one of them, and all of our developers have deployed the rest of them. The last thing is we need to unify the tooling that we use around running our applications. DevOps is more than just deploying code. It's about designing, deploying, configuring, observing, triaging, running our applications. That's what DevOps has started to become. And we need technology like platform engineering to help us do that in a scalable way. So we hope you give Massdriver a try and see how it can improve your business. This is where I wrap up. So I'm going to be hanging around backstage. Feel free to answer any questions. I'm going to do my best to answer them via chat. But at this point in time, I'm going to hand it back over to Corey. He's going to give us some closing remarks, and I think he may be opening it up to Q&A for anybody who decides to stick around. So thanks everybody for watching, and I hope this was helpful and enjoyable.
Hey everybody, thanks so much for joining us today. We really appreciate it. This is our first ever conference. Hopefully it went smooth. We've never planned one of these before. But if there's any questions, feel free to post them in the comment channel, and we'll try to address as many as we can. And also, I believe that our one of my teammates is currently pulling the name for the raffle, so we'll have that here in just a second. Thank you, Dot. Thank you, Will. Does anybody have any questions about the platform, about platform engineering? Happy to answer any of those. Also, if anybody's here from the Open Tofu traffic from the talk and has any questions about that, happy to share that as well. Doesn't look like there's any questions. Okay, cool. So we're going to be doing a number of raffles. We figure we just do the main one here, and then we'll send everything else via email. But for the 1 terabyte OLED Steam Deck, it looks like it's going to Minith Jane. I hope I didn't butcher the pronunciation of that. Minith, are you still here, or did you take off already? Minith may have taken off already. So we'll follow up with them in just a minute, send their email, and then we'll also be sending emails to the rest of the prize winners. If there's no other questions, again, I really appreciate the time today. I know the team appreciates your attention, and check us out at massdriver.cloud. We are Massdriver on Twitter and LinkedIn. I've been Corey O'Daniel. I still am Corey O'Daniel, I guess. Thanks so much. Have a great day.